Selamat pagi, Pak Hantoro.
Selamat pagi, Prof. Nyoman.
Selamat pagi, Bu Dessy. Wah, paling rajin Bu Dessy.
Sudah banyak sebetulnya, Prof. Prof. Didi juga sudah bergabung.
Mana dia? Prof bagus kita tuh mana itu dia?
Selamat pagi, Mbak Dessy. Pak Nyoman, Pak Hantoro, selamat pagi.
Prof Nyoman, selamat pagi.
Selamat pagi, Bu Eri.
Selamat pagi, Bu Eri.
Background Quindi.
Selamat pagi, Prof. Nyoman dan semua peserta seminar. Semoga sukses. Amin.
Selamat pagi, amin.
Tetap sehat dan semangat semua. Amin.
Amin. Selamat pagi Bapak Ibu semua. Very good morning.
Good morning.
Good morning Mbak Dessy. You. Good morning. Very good morning.
Yes, yeah. Very good morning to everyone.
Yes.
Kita mungkin menunggu Pak WR1 sebentar, nanti mungkin bisa dimulai.
Berarti urutannya Pak WR1 sambut dulu ya?
Nanti Pak WR1 nyambut terakhir sekalian membuka, Prof. Nanti dari laporan dulu, laporan dulu. Nanti.
Yes. Backgroundnya nanti. Assalamualaikum Prof Agung, Pak Dekan.
Salam di Pak Budisas.
Sehat.
Alhamdulillah maturnuun tungane
Ya, ini di tag team, Prof.
Oh siap.
Mantap.
Mantap. Home sweet home.
Wah.
Baiti janati.
Tadi malam sampai jam berapa?
7 pulang loh. 6:30 pulang.
Oh iya.
Kamu sampai Bang Ibu?
Dessy, Mbak Dessy.
Hai Sobat Bijak, tahukah Sobat, ada berbagai jenis investasi, diantaranya properti, saham, reksadana, tanah, emas, dan lainnya. Kali ini kita akan membahas tentang investasi emas. Saat ini, emas bukan sekedar perhiasan semata, namun juga investasi yang paling stabil terhadap inflasi, mudah diuangkan, mudah disimpan, dan mudah dibawa. Yuk, saatnya kita rencanakan finansial masa depan dengan berinvestasi emas bersama tabungan emas Pegadaian Syariah. Tabungan emas Pegadaian Syariah adalah layanan penitipan saldo emas yang memudahkan masyarakat untuk berinvestasi emas. Jangan khawatir, Pegadaian Syariah menjamin ketersediaan fisik emas yang kalian tabungkan. Dapat diakses online melalui aplikasi Pegadaian Syariah Digital atau datang langsung ke lebih dari 600 outlet Pegadaian Syariah di seluruh Indonesia serta agen Pegadaian Syariah. Apakah Sobat Bijak tahu, harga pembelian emas mulai dari ribuan rupiah saja dan terjamin kemurnian fisik emasnya. Soal keamanannya tak perlu diragukan lagi. PT Pegadaian merupakan BUMN yang berpengalaman serta diawasi oleh Otoritas Jasa Keuangan. Tabungan emas Pegadaian Syariah sudah sesuai dengan Fatwa Dewan Syariah Nasional Majelis Ulama Indonesia nomor 04/DSN strip MUI /4 Romawi /2000 tentang murabaha dan nomor 77/DSN strip MUI /5 Romawi /2000 tentang murabaha emas. Sobat Bijak, tabungan emas Pegadaian Syariah ini bisa dijual kembali, bisa dicetak menjadi emas batangan, maupun ditransfer antar rekening. Tidak hanya itu, tabungan emas di Pegadaian Syariah bisa dijadikan sebagai barang jaminan rahn atau gadai loh. Ada 3 cara pembukaan rekening melalui lebih dari 600 outlet Pegadaian Syariah dan lebih dari 4.000 agen Pegadaian Syariah atau melalui aplikasi Pegadaian Syariah Digital. Pilih menu buka tabungan, masukkan nominal pembukaan tabungan dalam rupiah, tekan tombol konversi untuk mengonversikan nominal dalam bentuk graf emas, lengkapi data nasabah apabila belum dilengkapi, pilih cabang lokasi pembukaan rekening, pilih metode pembayaran dan lakukan pembayaran. Selanjutnya, buku tabungan dapat diambil di cabang pendaftaran yang kamu pilih. Simple banget kan caranya? Jangan lupa untuk aktivasi finansial di cabang ya, agar kamu lebih mudah mengakses fitur-fitur menarik dari Pegadaian Syariah Digital. Mudah kan? Yuk mulai nabung emas di Pegadaian Syariah, tabungan Mas Pegadaian Syariah, tepat caranya, berkah hasilnya.
Diponegoro University has been moving ahead to be the best university in Indonesia by providing 13 faculties of undergraduate and postgraduate. Diponegoro University has graduated 300,000 qualified alumnus. Diponegoro University also establishes vocational schools to generate a ready-to-work alumnus. Holding the fighting values of Pangaran Diponegoro, such as honest, brave, fair and attentive, Diponegoro University keeps producing excellent alumnus nationally and internationally, while also contributing in the development of knowledge, technology, art, culture and exercise.
Diponegoro University now facilities, financial system, bureaucracy management, information system, as well as quality of human resources, quality escalation of three Dharma perguruan tinggi is the primary target of UNDI by stimulating the downstream of research outcomes that can be beneficially implemented for the society. We also keen to improve the quantity of national and international academic publication, as well as the number of doctorates and professors in
two important aspects of achievement, institutionally and student achievement. Diponegoro University has become a world-class university by being ranked 5th amongst almost 5,000 universities in Indonesia. Meanwhile, the students' achievement in both national and international scales of prestigious events are increasing. The vision to be an eminent research university is supported by the continued increase of research funding. The total research and civil service funding in 2018 is 123.7 billion rupiah. It consists of PNBP, the National Competition Research Funding, and Collaboration Research Funding. The intellectual property right becomes the indicator of significantly improved research. The patent consists of simple patent, patent, international patent, software and invention legal letter. To support the academic process, Diponegoro University has been improving the student facilities. Thus, the students will not only get the knowledge, but also the actualization space. For the academic service, Diponegoro University has built a central computerized system that includes the service for the online study plan and online registration.
Kompetisi di Undip yang sportif dan konstruktif memacu saya untuk terus berprestasi dalam akademik maupun non-akademik.
Didukung dengan fasilitas umum dan keakademikan yang lengkap.
Sehingga membawa Undip masuk 10 besar universitas terbaik di Indonesia.
Undip berada di daerah beragam budaya yang harmonis.
Yang pastinya Undip lebih baik.
Undip lebih baik. Bagaimanapun, Undip pasti lebih baik.
Ladies and gentlemen, before proceeding with the event, please take your comfort place. Also, most important, please kindly mute your microphone to ensure that this event runs smoothly. We will be starting soon. Thank you. Honorable Rector Universitas Diponegoro, Profesor Dr. Yos Johan Utama, Sarjana Hukum, Magister Humaniora.
Honorable Vice Rector Universitas Diponegoro.
Honorable speakers and moderators, honorable delegations, honorable distinguished participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning and best wishes to all of you. We thank God Almighty for only by His blessings and grace we can gather here at this event. We are delighted to welcome you to the 4th International Conference on Chemical and Materials Engineering, ICCME 2020. The theme of ICCME 2020 is the role of chemical and material engineering in ensuring food, water, and energy for sustainable development goals. My name is Fauzandi.
And my name is Risha.
We stand here in front of you today as your masters of ceremony. We will be here to guide you during today's events.
The Department of Chemical Engineering, Faculty of Engineering, Universitas Diponegoro organizes the 4th International Conference on Chemical and Materials Engineering, ICCME 2020, which supported by various local and international organizations and sponsored by Pegadaian Syariah.
We also would like to announce that this event is conducted using Zoom platform and can be streamed live from Undip TV official channel. We also would like to remind you to fill the attendance form that informed in the chat meeting for the administration of the conference.
Participants include researchers, practitioners, and students.
Ladies and gentlemen, we will start today's agenda by singing the national anthem, Indonesia Raya. Please kindly stay idle in the position for the anthem.
Thank you. For the next agenda, we would like to invite the chairperson of the organizing committee, Professor Dr. Insing Didi Dwi Anggoro, Master of Engineering, to deliver a report of the event. To Prof. Didi Dwi Anggoro, the screen is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning. Whom we respect, Director of Universitas Diponegoro, represented by the Vice Rector Academic and Student Affairs, Professor Budi Setiono, SOS Empol Admin PhD, Dean of the Faculty Engineering, Professor Dr. EIR M. Agung Wibowo, MM, MSc, PhD, Chairman of the Department of Chemical Engineering, Dr. Suherman, the keynote speakers, all presenter and participant. International Conference of Chemical and Material Engineering, or ICCME, is Universitas Diponegoro, Indonesia. The theme of ICCME 2020 is role of the chemical and material engineering in ensuring food, water, and energy for sustainable development goal. The event is designed to emphasize and find a new finding in chemical and material science technology and their impact on sustainable development goal. The conference will bring together scholars leading scholarship and experts from diverse background and application area in science. Ladies and gentlemen, the COVID-19 pandemic has forced and taught us to hold international conference online. Alhamdulillah, with the permission of Allah Subhanahu wa Ta'ala, the ICCME 2020 conference can be held online. We inform you that there are 8 keynote speakers from 7 countries: Indonesia, Malaysia, Brunei, India, Iran, Vietnam, and Japan. However, Professor Masaru Watanabe from Tohoku University, Japan, could not make a presentation due to other activities. Meanwhile, there were 179 papers and presenters from 5 countries: Austria, Japan, Saudi Arabia, Malaysia, and Indonesia. From these papers, 8 papers we selected to be published in International Journal of Renewable Energy Development, 5 papers in ASEAN Journal of Chemical Engineering, and 166 papers in UP Conference Journal. All journals are indexed by Scopus. On this good occasion, we apologize if the preparation and implementation of ICCME 2020 is still lacking. This is because we are working from home, making it difficult to coordinate directly. Thank you for all the committee who work responsibly and complement each other. Finally, welcome to join online ICCME 2020. Hopefully, it will be useful and increase our collaboration in this field of education and research, especially in chemical and material engineering. Thank you very much for your attention, and wassalamualaikum warahmatullahi wabarakatuh.
Thank you for the speech. We cordially invite Dean for the Faculty of Engineering, Professor Insinyur M. Agung Wibowo, Magister Management, Master of Science, Doctor of Philosophy, to deliver his welcoming remarks. To Prof. Agung Wibowo, the time is yours.
Yeah, thank you very much for the MC. The Honorable Vice Rector of Academic Affairs, the Honorable Head of Department Chemical Engineering, the Honorable Head of Organizing Committee, the Honorable Keynote Speakers, participants, students, ladies and gentlemen. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning. My name is Professor Muhammad Agung Wibowo. I am Dean Faculty of Engineering, Diponegoro University. It is a great pleasure for me to welcoming all of the participants for the ICCME 2020. I do really appreciate for all of the participants to join this international conference by online due to the COVID-19 pandemic. Ladies and gentlemen, I would like to take this opportunity to extend my warm welcome to the keynote speakers. They are Dr. Insinyur Hasa Wardana M.Eng, Coordinating Minister for Economic Affairs Indonesia, Professor Dr. Insinyur I. Nyoman Widiasa from Diponegoro University, and then Professor Masaru Watanabe from Tohoku University, Japan, Professor Dr. Ahmad Zuhairi Abdullah from University Science of Malaysia, Professor Dr. Muhammad Kamil from Aligarh Muslim University, India, and Associate Professor Dr. Reza Damarnejad from Arak University, Iran, and Assistant Professor Dr. Haslisa Bahruji from University Brunei Darussalam, and Dainet Phu PhD from Nguyen Tat Tan University, Vietnam. This International Conference of Chemical and Material Engineering 2020 will be an international forum for the researchers, students, industry, and government in communicating their research and development results on fundamental and application of chemical and material engineering. I do hope that this event could facilitate the formation and strengthen the network among the participants of the conference for improving the quality and benefit of the research. Finally, enjoy your time for this international conference. Thank you for your cooperation and have a great time to join this international conference. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Agung, for the welcoming remarks. For the next agenda, we would like to invite the Vice Rector of Academic and Student Affairs, Universitas Diponegoro, Professor Budi Stiono, Sarjana Sosial, Master of Policy and Administration, Doctor of Philosophy, to deliver welcoming remarks and officially opening the event. To Professor Budi, the time is yours.
All right, thank you very much. Good morning, everybody. The honorable keynote speakers, participants, and also committee members. Welcome to Universitas Diponegoro. Our Department of Chemical Engineering at Faculty of Engineering, Universitas Diponegoro, today proudly presents the 4th International Conference on Chemical and Material Engineering, ICCME 2020, with a theme of Application of Chemical and Material Engineering for Sustainable Development Goals on Food, Energy, Materials, and also Environment. This conference will be held for today and tomorrow, so 2 days. You will be with us, but we wish that the collaborations and also networking will last longer than just the conference duration. Universitas Diponegoro, or later we say as Undip, is one of the best, foremost, and oldest universities in Indonesia. As you know, Undip has been home for more than 54,000 students, and it's ranked in the top 10 national university. Undip also gained its reputation worldwide, namely top 400 THE World University Ranking for SDGs and top 1000 US World University Ranking in 2020. For the student achievement, Undip is acknowledged as the best 3 of national rank by QS World Graduate Employability and Universities in Asia by Unirank for ICU.org respectively. We aim to become world-class university in which providing excellent education has become one of our main focuses during the last 5 years. Sustainable Development Goals, or SDGs, has been a highlight these days to the world due to its urgency to improve human welfare. The theme of this conference is part of the standpoint, which is related to the role of chemical and material engineering in ensuring food, water, and energy sustainability for industry and also for our society. The conference will emphasize on knowledge transfer amongst the participants, including researchers, students, and also other stakeholders. We wish that despite virtual event, enthusiasm and also contributions during the conference will not get affected. We also expect that through this event, perspective and well-established collaborations will get even stronger and beneficial for all participants and also all parties related to this conference. Last but not least, I would like to thank to our keynote speakers here for the availability on agreeing to share the knowledge on this conference. We thank to Dr. Insinyur Harsawardana, Magister Engineering, practitioner on palm oil industry in Indonesia. Also Professor Dr. Insinyur I. Nyoman Widiasa, STMT, our colleague in Universitas Diponegoro. We also thank to Professor Masaru Watanabe from Tohoku University, Japan. Thank to Professor Dr. Ahmad Zahiri Abdullah, University of Science, Malaysia. Also thank to Professor Dr. Muhammad Kamil FIE from Aligarh Muslim University, India. Also for Associate Professor Dr. Reza Dafar Nejat from Arak University, Iran. Assistant Professor Dr. Hasliza Bahruji from University Brunei Darussalam. I've been there a couple of years ago. And also Daifat N. Pho, PhD from Nguyen Tat Thanh University, Vietnam. I also been Vietnam for several times. So thank you very much for all the speakers for your kindness to share your knowledge in this conference. Ladies and gentlemen, on behalf of Rector Universitas Diponegoro, I officially open this event and we look forward to having great outcomes and as well as fruitful collaboration in the future. Have a great discussion ahead, and once again, thank you for your participation. Thank you and good morning. Back to you, MC.
All right, thank you. Before we continue to the next agenda, we would like to invite all of the participants to pray together according to your beliefs for half minutes for the successful of the event.
Thank you. Ladies and gentlemen, we'll proceed to the photo session. Please kindly turn on your video as we will about to take a screenshot all the gallery from frame 1 until the end. Please be patient.
Thank you. Ladies and gentlemen, we will soon continue with the plenary session. Thus, please have a seat and make yourself comfortable. We kindly remind you one more time to mute your microphone to ensure that this event runs smoothly.
Ladies and gentlemen, we will now begin the plenary session 1, followed by an interactive discussion.
3 remarkable speakers will present the plenary lectures.
The first is Professor Dr. Ahmad Zuhairi Abdullah, a professor of chemical engineering from University Science Malaysia.
The second is Professor Dr. I. Nyoman Widiasa, a professor of chemical engineering from Universitas Diponegoro.
And the third is Dr. Hasliza Bahruji, assistant professor at Center of Advanced Material and Energy Science, University Brunei Darussalam.
This session will be moderated by Professor Dr. Andri Cahyokumoro, Sarjana Teknik, Magister Teknik.
Professor Andri Cahyokumoro, Sarjana Teknik, Magister Teknik, received his doctoral degree from the University of Malaya, Malaysia. He is currently working as a lecturer at Chemical Engineering Department, Universitas Diponegoro. Professor Andri Cahyokumoro has an incredible research experiences in the field of food and functional food engineering, biochemical engineering, and utilization of local biodiversity.
He also received a College Award Young Inventor Award and Advisor for National Student Science Week in 2018. Prof. Andri Cahyokumoro published number of research articles in many prestigious peer-reviewed international journals and several books. He is also an editor-in-chief Reactor Journal and Scientific Committee of International Reputable Journal. So, without further ado, please welcome our remarkable moderator, Professor Dr. Andri Cahyokumoro, Sarjana Teknik, Magister Teknik. To Prof. Dr. Andri Cahyokumoro, the screen is yours. All right, please be patient. Wait for a minute.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. We are currently from the Department of Chemical Engineering, Faculty of Engineering, Diponegoro University, Semarang, Indonesia. This morning, we are proud to arrange our very lovely program. This is the fourth session of the International Conference on Chemical and Material Engineering 2020, held by the Department of Chemical Engineering, Faculty of Engineering, Universitas Diponegoro. And this is the first plenary session. We are proud to share with you. We have three speakers coming from three different countries, which is from Malaysia, from Indonesia, as well as from Brunei Darussalam. In the first session, we have Professor Tan Sri Dato Dr. Ahmad Jurari Abdullah Pitek, FMIC. He is the professor from the School of Chemical Engineering, University Science Malaysia. The second one, we have the Professor Dr. Nyoman Widyasa, Sarjana Teknik, Magister Teknik from Universitas Diponegoro. And the third, we have Dr. Hazliza Baruji. She is from the University Brunei. Before we begin with the plenary session, we would like to provide brief information, the curriculum vitae of this expert, Professor Dr. Ahmad Jurari Abdullah. Technology of the food technology from University Science Malaysia in 19. Environmental engineering as well as oleochemical engineering. Currently, he is the member of the Fellow Institute Kimia Malaysia or Malaysia Institute of Chemistry, Fellow Institute of Engineering Research and Publication, Chennai, India, and he joined many more professional membership. In regard to Professor Dr. Nyoman Widyasa, he is a professor in the Department of Chemical Engineering, Faculty of Engineering, Universitas Diponegoro. He obtained his degree from the Department of Chemical Engineering, Universitas Diponegoro. He obtained his master degree from Institut Teknologi Bandung, and he followed his education in the same institute and finished in 2005. Accordingly, Dr. Hazliza Baruji, she obtained her degree from University Technology Malaysia in industrial chemistry and followed her education for master in physical chemistry. And finally, she got her PhD from Hardi University, also in physical chemistry. In 2011, she is the member of the American Chemical Society. She is also the member of Royal Chemical Society. She is also the member of UK and Ireland Semiconductor and Photochemistry. From 2013 to 2017, and many more memberships. She is an expert in the carbon dioxide fixation studies, photocatalysis, water splitting, as well as renewable energy. Without further ado, we would like to begin the first plenary session. We would like to invite Professor Tan Sri Dr. Ahmad Zurairi Abdullah to present his speaker. Professor Ahmad Zurairi Abdullah, the time is yours. Welcome, Professor Ahmad Zurairi Abdullah.
Okay, thank you very much. Professor Dr. Andre Cahyo Kamoro as a session chairman for this plenary session this morning. Assalamualaikum warahmatullahi wabarakatuh. Hopefully you can hear me. First of all, can you hear me?
Yes.
Okay, good. Alhamdulillah. Right, I would like to take this opportunity to thank the organizer of this particular conference, especially to Professor Didi for extending an invitation to me to join the conference. So for this particular session, I'll be sharing a certain project of mine that I involved in for the last several years. And particularly this is about the use of catalysts to convert glycerol to value added polyglycerol, and more specifically it is diglycerol. Let me check how to share it. Share screen. All right. You see it? Right? Is it clear in the first place?
It's clear. It's clear.
Okay, alhamdulillah. Right, again. So it is actually about pole geometry. Okay, this phenomenon is very important in the catalysis, and in this particular case, I use calcium lanthanum oxide supported on MCN41, which is a mesoporous material, all right, as a catalyst for the selective esterification of glycerol to polyglycerol. So in this particular case, it is about the esterification process, and it is about the conversion of glycerol to polyglycerol. Right, and first of all, I'd like to take this opportunity to introduce you. I believe some of you might be aware of this very much because Malaysia and Indonesia, basically, we are main producers of palm oil into the world, right? And it is actually about several different stages of oleochemical industry. In this particular case, palm oil industry, we are talking about upstream, where we produce a full fruit branch. We also have another one which is midstream, and it is concerning the milling of the palm oil, and the last one is the oil refining and fractionation. And in this particular stage of palm oil industry, we produce a lot of products, and in this particular case my interest is on the glycerin. Right, my particular interest is for the conversion of glycerin to some value-added chemicals. And we produce some other products which are of a different interest, which are of different use in other types of industry. In this case, it is about glycerin. Right. Before we proceed any further, I would like to introduce you to some chemistry about palm oil. And okay, palm oil basically consists of some oil components and non-oil components. And for palm oil, the oil components of palm oil, it consists of glycerol and fatty acid. Okay, the molecule is actually triglyceride, consisting of one molecule of glycerol. Attached to it is we have three molecules of fatty acids of different kind, of different length, of different natures. And we may have some other components such as tocotrienol, carotenoid, lecithin, and so on. Right. In this case, it is actually about glycerol. Right. What to do with it, and where it is actually coming from, and in what kind of industry is coming from. Right. Because in this particular case, we produce palm oil, and glycerol is basically a component that can be generated from palm oil, and it is actually produced in a very abundant amount, but unfortunately it has very limited uses, right? And we can see some properties of glycerol. It is actually a molecule, organic molecule consisting of 3 carbon, and attached to each carbon is one group of hydroxy functional group. So it is actually a molecule consisting of 3 OH group, and because of that, it is miscible in water, it is miscible in alcohol, and not only that, it is actually having some hydroscopic activity, so that it is actually useful to be used in some products that require retention of moisture in the product so that it won't dry up, right? So that is something usually the traditional use of glycerol in the industry. And let's see some scenario in terms of the production of glycerol, right? And it usually, it is actually coming mainly from biodiesel nowadays. Previously, it came from oleochemicals such as fatty acid splitting industries, right? And more recently, it is actually biodiesel that it was the main producer of glycerol. We can see here the trend. Okay, in terms of glycerol product, biodiesel production, we can see a very steady, very drastic increase from year to year, from 2003 to 2020 here. Right, we can see that the trend is very drastic increase here, but we can also see correspondingly the crude glycerol production is increasing with years. Right, so because it follows the production of biodiesel, because it is coming from biodiesel industry, it is actually produced about 10% of the capacity, 10% of the amount of biodiesel being produced. It is actually about 10%, right? So because of that, if we have increase in the biodiesel production, means correspondingly we have increase in the glycerol production. So because of the market, and we can see in a red line here, a very steady decrease in the price. So we have a constant there. We have increased production and we have reduced price of the glycerol. So we have a constant there because we actually have very limited uses of glycerol, and because of that, it is even considered now as a waste to get rid of. Too bad, because it has some uses, it has some application in industry, but because of the huge amount of glycerol being produced and very limited uses of it, it is even considered as a waste now. So it is too bad, right? So in my research, I focus on the conversion of glycerol to some products, and in this particular research area, we focus on mono and polyether. We focus on mono and polyester, acrolein, glycidol, and glycerol-carbon, and many other uses or many other product can be generated from glycerol actually. But of course, we need to be focused in our research so that we can go deep into the topic and try to discover more. So in this particular case, it is about the reaction, esterification reaction to produce diglycerol, triglycerol, and so on. Right. So basically, for the conversion, we rely very much on the use of catalysts. And in this particular case, in this actually area, the discussion could be centralized around the use of either microporous or mesoporous catalysts, right? Microporous, mesoporous catalysts, because they are actually the main type of catalyst being used in the industry, while microporous has limited uses because of the large pore and because of the pore surface area. So in this particular case, we want to explore into mesoporous type of catalyst because they are proven to be useful for this type of reaction, while usually microporous catalysts could be applicable more towards the gas phase industry involving small molecules. So this might not be applicable in our case. So the focus here is mesoporous. And not only mesoporous, we have ordered for mesoporous catalysts, so that we can have very narrow pore size distribution, while at the same time the size of the pore could be within meso size range, which is large enough to allow the diffusion of molecule, diffusion of product from the catalyst, while at the same time it allows us to have very large surface area, right? So that is something useful about mesoporous material in this particular case, all right? For other reaction, mesoporous might not be the right candidate, but in this particular case, to us, it is the right candidate because it can serve a certain purpose the way that cannot be offered by microporous right? Definitely they cannot be offered by microporous material. So for this case, we use SBA 50, sorry, MCM 41 in this particular case. So it is actually material of mesopore, and we introduce some functional group into it, and it is actually produced through the formation of a micelle, through the formation of a structure like this, and followed by calcination. I believe this is something that could be known to some of you who actually venture into catalysis. So I don't want to further too much I don't want to give too much deliberation on the formation of MCM 41, because it could be known to many of you. But in this particular case, we want to have a certain catalyst that can actually support the reaction by providing high surface area. But not only that, we don't want to satisfy with that. We want to get, or we want to have a catalyst that can direct the reaction towards the desired product and retarding some undesired reaction to occur, so that we can limit the amount of undesired product, which is something useful in this particular case, because the reaction involves a number of different reaction steps to produce different products. And here we are talking about one particular product, which is diglycerol, right? From glycerol, we produce diglycerol with the one larger molecule, right? So for mesoporous catalyst, usually in terms of the diffusion, it could be somewhere within slightly towards the end of Knudsen diffusion. If you study fundamentals of diffusion, basically you could be knowing this, and it could be somewhere here, right? So basically it is about the role of pores in directing a certain reaction to occur and disallowing certain other reaction to occur, right? So that is something in the simple words about this. We are talking about shape selectivity here. Shape selectivity means we have reactant, we have the catalyst here. The many reaction will take place within the catalyst pores, but we want only a certain product to be generated. Okay, something like this. We have several products that can be interchangeably formed in the pores, but once we have the diffusion out of the products from the catalyst, we want only a certain product. And other product is actually we want it to be retarded, or we want it to be suppressed, so that won't be so much of the undesired product that will present in the product stream here. It is about the role of the pore, the geometry of the pore, the size, the shape of the pore that can dictate a certain reaction to take place and certain other reaction to be suppressed. All right, that is in the simplest word that I can mention about this. So in this particular case, the reaction involves glycerol, and upon the combination with another molecule of glycerol, with the presence of a certain catalyst, with the removal of one molecule of water, we will form diglycerol, which is our desired product. Diglycerol, and another one is triglycerol. Those two are useful, but more particularly diglycerol is more useful as compared to triglycerol. Where do they find the application in the industry? They can be used as oxygenated fuel additive. They can be used as modern, okay? They can be used as a lacquer material. They can be used as an ingredient in the formation of ink, and as a humectant. All right, bear in mind, just now I mentioned to you about the high affinity of glycerol towards water. All right, it is able to retain water in the product, so that it is actually become or function as humectant. And in this particular case, this is actually better as compared to glycerol, because this is actually having more OH group, which is more hydrophilic, and because of that, it is more functioning as a humectant. Right? Same goes with some other products here. Basically, we want more diglycerol, but we do want, or we try to suppress the formation of triglycerol. Okay, so basically, the reaction involves a number of different steps of reaction, and we can have products of different kind. This is alpha alpha, this is alpha beta, this is beta beta of different molecular size. Okay, we have molecular size, molecular configuration. So the only thing is we want to direct the reaction towards the desired product. And let's take a look at the result using homogeneous catalyst. We can use a homogeneous catalyst as well as liquid catalyst, right? Basically, we have glycerol conversion versus time. We can have this kind of a pattern, increase in the conversion, but we have slight increase in the formation of the diglycerol. Okay, initially increase, but after that we have a decrease. What does it mean? It means it start forming initially, but after that further reaction will take place. We can see here, this is about further reaction. And we don't want this. We want these products. We don't want this product. So because of that, we have to suppress this product. Okay. So basically, homogeneous catalyst is unable to do that. Okay, that much. And we try to see some other result here in terms of the CEO versus SRO. Those things are basic catalysts. We can see here, and basically they have a sufficient basicity and sufficiently. It could be sufficient surface area to add. Okay, in the liquid phase reaction, because maybe it could not be sufficient for gas phase, but for liquid phase it could be sufficient, right? We can see the difference. We can see the performance of the catalyst in terms of the conversion, in terms of the selectivity. All right, again, it is about increase in the conversion, but in only initial increase in the selectivity of the diglycerol. We are talking about diglycerol here, right? But after that, it goes down. Unfortunately, it goes down. It means we have undesired formation of triglycerol and some oligo materials, larger materials, because of the reaction that keep on occurring. All right, during the reaction, within the reactor, right? And in terms of the triglycerol yield, right, we can see increase here, and that's the indication. We have a decrease in terms of the diglycerol formation. We have increase in the triglycerol. So it is too bad. This is undesirable as compared to diglycerol. Right, so for this case, we use the same catalyst CaO, which is actually a macroporous type of material rather than mesoporous. We can have a pattern of conversion versus time at different catalyst loading. This is actually the typical formation, typical results for this type of experiment. But we can see we have sufficiently high conversion versus time. But again, when it comes to the yield of diglycerol, we have initial increase, but now it is increasing until about 8 hours into the reaction, and it is achieving a quite high yield of diglycerol, but only after that it goes down, right? And if we study the reaction at different reaction time at at different temperature, we can see a general pattern when it comes to the conversion. This is something understandable because a higher reaction will create or will allow more reaction to occur, right? And we have the yield of diglycerol. We want to see whether or not this reaction, this conversion leads to the formation of diglycerol, which is our desired products here. We can see here that if the reaction is extended, the reaction is carried out at increasing high temperature, we can have better formation of diglycerol until a certain point here is about 250 degrees Celsius. It reach the peak, which is at about 20% of yield of diglycerol, and after that it goes down, which is something desirable in this particular case. But at the same time, it might not be good enough. So because of that, we synthesize different combination of Ca, La, and bimetallic of Ca, La to be incorporated into MCM41, which is a known mesoporous support, right? We can see that they are actually having quite a significant high surface area to perform in the reaction. And at the same time, they have total pore volume of somewhere within 0.2 to 0.8 roughly. And the pore size, most of them are actually having pore size within the meso size range, which is desirable. And definitely they have high basic strength, which is definitely a requirement in this particular reaction because we use Ca, La, and the combination of Ca, La. Basically, those are basic materials, right? And upon observation under TEM, this is something typical that can be seen for a mesoporous material. We have an arrays of rather or relatively straight channels or pores, and the size of this pore could be within the meso size range. So in a way, we can conclude that we successfully produce mesoporous catalyst. But definitely the formation, the success could be different upon the introduction of different amount of metals, right? That is something understandable actually. Okay, more metal be introduced, basically it will disturb the structure. So because of that, we have limited success, but at the same time, we try to limit not to exceed more than 30%. So here we are talking about mostly 10%, 20%, only those level, right? And upon
you have another 3 minutes to present.
3 minutes. Okay, right.
Okay.
Basically, the mesopore materials is actually having type 4 isotope, which is typical for a mesoporous catalyst. So again, it is actually an evidence for the success to produce mesopore materials. Okay, this is typical, but at the same time, we can see that the surface area is high. Okay, the pore volume absorbed is high to indicate that surface area is actually high. Okay, drop a bit, but still high. Right, let's see the result in terms of the glycerol conversion, and at the same time, the diglycerol formation. This is conversion, this is diglycerol. All right, increase initially and decrease gradually after that. And we, for the conversion, increase, okay, retain at a certain level, right? But of course, it is actually dependent on the specific type of catalyst being used, right? This is something typical as mentioned to you just now. But again, it is actually higher in terms of the conversion. It is actually higher in terms of the yield. Just now I mentioned about 20%. Now it is about 40%. All right, let's see the difference, right? So basically, the reaction involved within the pore, okay, involving the molecular arrangement between we have 3 different isomers here: alpha, alpha prime, alpha beta, and beta beta, depending on the OH group, okay, that is forming the bond between them, so that you can have different isomers of diglycerol molecule. So here molecular arrangement will take place, and let's see which one is actually more favored. For CaO, this is actually the highest, okay, alpha prime, which is the straight isomer, which is actually the highest. But in this particular case, in terms of the mesoporous material, it is actually shifting from here, okay, to the alpha beta isomer. So we can see that this is actually the role of pore, okay, in detecting the molecule, so that it is actually not forming the straight, the linear, it is forming a branch, right, in involving the attachment of the NOH to the second OH of the second molecule, right? So that is something different when it comes to the use of mesoporous catalyst in this particular case as compared to CaO. Okay, so basically here, yeah, of course, it's come from different reaction, different runs, and a number of different runs of reaction. So basically, I have limited time to discuss. So I'm just putting to you some typical result to be observed here, right? Typical result to be observed. So as a conclusion, basically, we can say that crude glycerol is now regarded as waste because it has limited uses, and it is produced more than the demand of it, right, in industry. So glycerol can be converted into value-added products, and in this particular case, it is polyglycerol or diglycerol in a more specific manner, diglycerol. And in this particular case, we use CaLa combination incorporated into MCM41, which is actually ordered mesoporous catalyst. And basically here we have quite good diglycerol yield, which is about 42, an increase of about 20% as compared to only Ca alone, which is known to be very highly basic, but unfortunately the desired product is not much as compared to this type of catalyst. All right, 42% as compared to about 20 earlier. So here it is actually the conclusion that can be generated from this study. Good geometrical constraint played a role in changing the distribution of the glycerol isomer, with the higher preference toward the formation of alpha beta isomers, right? This is particularly the isomers that is actually favored in this particular reaction because of the role of the geometry of the pores, okay, of the catalyst. Right, so with a very limited time given to me, so that's all that I can share. So definitely I'm welcoming you to offer me some question. Jessica, you have anything to be clarified in mind? So I'm open to any kind of question. Thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Ansari. It's very good presentation, which convert glycerol as the waste into new product by designing so many type of catalyst, basically from CA and LA with MCM41 catalyst. And I open to the question from the audience. So you have any question, please write here in the chat room, or you can directly ask to any question. Okay, because I think it's the organizer asked me to proceed with the next presenter. So I would like to invite the second presenter. We have our beloved professor here in our department. We have Professor Gunawan Widiasa. He will be presenting his research work as well. And then later only we will discuss further with discussion, because we are waiting for the question from the audience as well. So the time is for Professor Gunawan Widiasa. The time, welcome Professor Gunawan Widiasa.
Thank you, Prof. Andre, the chairman of this session. You can see our PowerPoint.
Yes.
Yes, sir.
Good morning, ladies and gentlemen. Selamat
Good
pagi,
morning.
Bapak dan Ibu. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera buat kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Firstly, I would like all to thank the committee of this seminar for inviting me to join in this seminar. In this morning, I would like to present about our experience in membrane application of water treatment and wastewater cycle in Indonesia. Our presentation consists of 6 parts: water access in Indonesia, membrane processes for water treatment and wastewater recycling, experiences in water treatment, experiences in wastewater recycling, emerging application, and conclusion. Indonesia is a tropical country with the annual freshwater availability average 15,500 meter cubic per day. This amount approximately 25 times in the world availability, around 600. Indonesia can be classified as a country with economic water scarcity, in which quality doesn't match to the need, and financial limitation to boil and processing and distribution system. Now, many countries consider sufficient water availability is important role for national security, food and energy supply, and even social life. National Socio-Economic Survey by BPS 2017 finding that the household in Indonesia with access to proper drinking water just 72%. Main type challenges of this fact is Indonesia has nearly 17,000 islands from Sabang to Merauke, with population more than 260 million, with a growth rate of 1.4% per year. Of course, it is not realistic to provide centralized drinking water system for people in Indonesia. The other challenges is global climate change, forest clearing in water catchment area, and investment limitation to build water infrastructure. We know the best process for water treatment in freshwater supply is hydrological cycle. Surface water evaporate to the atmosphere, and then the vapor condense and precipitation and back to the surface from the surface and groundwater. We can get fresh water from lake, river, spring, and deep well. The natural process now is inadequate because the environmental demands and drastically increase in water demand in the world. This condition has drive the growth of saline water desalination and wastewater recycling in the world. We have a long journey, 20 years. We research and development in water treatment and wastewater recycling. Start from screening test and application test to search the best membrane for its case application, until to continue plant efficiency improvement based on operational and maintenance data. Semi-permeable properties of the membrane, that is a selective mass transfer, is able to remove color, bacteria, virus, heavy metal, salt, and other toxic components from the water. It is the advantages of the membrane for water and wastewater treatment. We have two basic form of the membrane, hollow fiber and flat sheet. And then the flat sheet membrane have configuration, flat and frame, and spiral wound form. There are many types of membrane processes: microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. This is the membrane processes have a key parameter is pore size or hydrophilicity and transmembrane pressure as a driving force. And then electrodialysis and electrodeionization is the membrane processes based on the membrane conductivity and electrical current. And then membrane distillation, the effective of the membrane process depend on energy source. If we have energy waste, the membrane process may be competitive to the other membrane processes or classical water treatment technology. And finally, membrane bioreactor combine activity slot and membrane properties. Now has the membrane process is rapidly growing to recycling in wastewater. The best performance of the membrane, we can combine two or more membrane processes, well known as integrated membrane process. For example, we can combine MBR and RO system for wastewater recycling. In our work, start from laboratory to commercial scale, we conduct a screening test to find the best membrane. And then we conduct application test to find operating data. And finally, we conduct a pilot plant test to find engineering data. The data is important for engineering design and operational the plant. After fabrication and installation, we continue to assess based on operation and maintenance to plant efficiency improvement. We have a lot of large-scale membrane system and a pilot plant system to assess industry in a real condition. Regarding to water treatment, we will talk about water refill system. Maybe it's the one of the membrane application in the world. And then we talk about a mobile water treatment system. And finally, we talk about conversion of saline water to fresh water in Indonesia. This is the figure of various capacity of refill drinking water in Indonesia, well known as air minum isi ulang. Yeah. The idea comes from the fact that because the price of bottled water is quite expensive for some people in Indonesia, the presence of refill drinking water can reduce transportation costs from factory to end user. And then many people in Indonesia can get safe drinking water in low price compared to bottled water. What is the problem of the system? Membrane has clogged in less than 3 months. So far from economic lifetime of the membrane that generally more than 3 years. Yeah. And then we assess what is the cause of the problem. We complete the system with auto flushing system and develop membrane cleaning procedure to enhance membrane lifetime. From the figure, we can see membrane performance is stable. And then by two-step cleaning, alkaline cleaning and acid cleaning can restore the membrane performance more than 70%. This is a mobile water treatment, especially designed for produce drinking water, clean water and drinking water and clean water that can produce 1,500 liter drinking water and 2,000 clean water. This design especially for refugee camp that is far from the normally facility. The design emphasizes on the easy mobilization from fabrication workshop to place of the system. This is the one breakthrough of the UNDIP development to contribute to the society in Indonesia. We know millions of fresh water is produced from saline water per day, and RO system step by step replace the thermal desalination. Until now, skeleton desalination plant in Israel is still the biggest SWRO system in the world. The growing of application membrane technology for brackish water and seawater desalination in Indonesia is rapid growing in the 10th past year. Yeah. Application most for power plant generation and hotel. Our project in this field to boil our SWRO system at Indonesian fishing port in Jakarta with capacity 1,500 meter cubic per day. The unique design of the system is by government regulation don't allow we to make beach well, and then we conduct engineered gallery water intake to supply raw water of the system. And the other, our project is upgrading from BWRO to SWRO in Anantara, Bali. This is the unique case. The salinity of the raw water increased from 7,000 to 20,000. And how we can re-engineering the system to process that water. In wastewater recycling, we should change our perspective. Yeah. We should consider wastewater is valuable resource, not a cost center in industry. And we have a dream to create income from wastewater. This is a perspective to realize wastewater recycling. Crude oil refinery in Indonesia is a strategic industry to convert crude oil to fuel oil. Indonesia has 6 active oil refinery and 2 refinery ready to boil and processing around 1 million barrel crude oil per day. This process requires 300 liters of water per barrel of crude oil and produce 40% of wastewater. We are surprising about rethinking design approach in refinery plant. Change from one true cooling system use seawater to open recirculating cooling system that use fresh water. This is a big opportunity to use wastewater recycling for cooling water makeup. We conduct a pilot plant skill test in a real condition at one of a refinery in Indonesia. This pilot plant test indicate from technical view of point, the membrane system can convert effluent wastewater to cooling water makeup. The main parameter for this application is silica contents that is not bigger than 15 milligram per liter. For recycling domestic wastewater, we remember with implementation of green building in shopping center, hotel, office building, apartment, real estate. The recycled water can be used for lavatory, cooling water, irrigation. In this application, we integrated a membrane system to existing facility that is improve the water quality from effluent standard to reuse purposes. This is our project in wastewater recycling. Use sand filter, ultrafiltration, carbon filter, and finally chlorination. This is the project in one of shopping center in Bekasi. And then we have a project in shopping center near to the sea. Interesting of this application is we use raw water mixed from effluent water and brackish water. It is not a common design use make raw water. We use a sand filter, ultrafiltration, reprocess unit, and final disinfection unit. This is integrated membrane system. The system start to operate at March 2013. And then we assess possibility of application the use membrane. This membrane, we assess the membrane properties, the membrane selectivity, and we can conclude the membrane can be used for pretreatment of the system. And finally, there are 2 emerging applications in Indonesia: aquaculture and microalgae production. This is our research in screening test to find the best membrane in application of recirculating aquaculture system. we find that membrane, ultrafiltration membrane with 100 kilodalton is the best of the application. And then falling is the classical bottleneck of the membrane application in this application. And then we have a project with a pilot plant test in Nusa Dua, Bali. The target of the project to convert effluent water from waste stabilization from to clean water and to concentrated microalgae. Clean water can be used for gardening, and concentrated microalgae can be used for liquid fertilizer. From this presentation, we can conclude Indonesia consider the availability of water in sufficient quantity is important for Indonesian security, food and energy supply, and even lifestyle. Membrane technology can provide consistent quality assurance for drinking water production, especially for refill drinking water, and able to conversion of brackish or seawater to freshwater and convert wastewater as a cost center into valuable resource. And finally, we can state Diponegoro University has adequate research and assessment facility, expert and empirical experience to can contribute to society, especially in water and wastewater facility. Thank you very much. The time we back to Prof. Andri. Thank you.
Okay, thank you very much, Prof. Nyoman Widiasa, for his speech and how we prepare water and how we used wastewater and produced a new water, where our neighboring country has been done last in the past, and we are currently in this. And this is very long journey of Prof. Nyoman, how to prepare water, which is the basic needs of everyone's life. Thank you very much to Prof. Nyoman. And we move to the third presenter. Before we move to the question and answer, we move to the third presenter. I would like to invite Dr. Hazlina Bahruji from Unity Brunei Darussalam.
Hello, hi.
Hello, how are you?
Yeah, I'm gonna share my screen. Yep.
Okay, now it's your turn. Thank you very much, and I deliver the time to you.
Okay, thank you very much for invitation from the organizer. Wait, I'll need to. Can you see my screen now? Okay, clear?
Yes, very clear.
Okay, thank you. Okay, let me, okay. Now I can see myself, I can start. Okay, so I'm Hasliza from University Brunei Darussalam. So if anybody have been to Brunei, Brunei got four universities, and University Brunei Darussalam is the oldest university in Brunei. Even though the oldest, we only been 30 years since the first day we opened as an institution. So what I'm going to talk today is about green hydrogen production energy, basically from photocatalytic water splitting. And then if you are interested to know more about Brunei or thinking about research collaboration, you can always contacting me at this email. And then this is a few pictures of the university and Brunei as well, if you are interested. But at the time, we have COVID situation that don't let us to travel. Hopefully when the COVID settles, we can start travel again, and then you are welcome to visit us in UBD. So why I want to talk about this is because we are really concerned about fossil fuels as our sole energy sources, which is, we know that the fossil fuels, when we combust them to get energy, we will increase or release carbon dioxide in the atmosphere. And then this is the, when you look at the figure here, this is basically look at the carbon dioxide level in UK since 1,400 years. And you can see that basically the rate, the level is pretty much similar until 1,800 years. 1,800 is when we're starting to see a surge growth of carbon dioxide to reach beyond 400 ppm level. So when it reaches this level, it means that the carbon dioxide in the atmosphere is no longer reversible. So this is actually because of the shift of the industrial from the non-machinery system into machinery system because of the generation of this coal machine. So what we're going to do here, we look at hydrogen as an alternative energy to that by having this hydrogen energy, we basically try to control the release of carbon dioxide from environment by creating a system that relying on hydrogen as the energy source. So when we talk about hydrogen, the best way to generate hydrogen is from water splitting. And because we know hydrogen is the, water is the most abundant source of hydrogen. However, when we look at hydrogen water splitting, it's basically a very high endothermic process. It requires 240 kilojoule per mole. So without catalyst, the energy is very high. By having catalyst, it basically lower down the thermodynamics, so it can be done under environment, ambient environment. So which in this case, we're looking at how thermodynamic energy can be consumed, can be supplied by energy from light, which is anything photon with the energy below 500 nanometer of wavelength can catalyze this water splitting into hydrogen and oxygen. And then we also go currently hydrogen being generated in the industry by steam reforming process, which is a reaction of natural gas with water and to give hydrogen and carbon monoxide. And this happened at very high temperature, about 1,200 Kelvin, and also at high pressure around 25 bar. And then we look at hydrogen as an energy source. When you compare with petroleum, methanol, and methane, we can see that hydrogen energy over a kilogram of hydrogen is actually really high compared to petroleum, methane, and methanol. So there is a potential of using hydrogen as energy. And then when we look at hydrogen as a whole, it only generated water during the combustion. So it's ideal choice of using hydrogen as a source of energy. And when we look at how we try to split water using photocatalytic reaction, we have to look at titanium as a semiconductor. This is basically the most stable, the most widely investigated, and having high activity compared to the rest of the semiconductor, even though the semiconductor work in the visible region. So what happened is, titanium allow absorption of light at 380 nanometers, but for water splitting process, we require metal as a co-catalyst. It won't happen without metal as a co-catalyst. And most of the reason studies, they put some organic sacrificial agents, for example, alcohol or sugar, to basically improve the activity to generate more hydrogen. So we're going to look at different types of metal catalysts, for example, platinum, gold, and palladium, and try to understand how these metal catalysts improve the activity of titanium for hydrogen production. So basically, when we talk about photocatalytic reaction, there is two types of reaction involved. First is aerobic reaction, and the second one is anaerobic reaction. The differences between aerobic and anaerobic is the presence of oxygen in the system. So basically, when we do aerobic reaction, we have oxygen. So it doesn't really matter if you have metal or not, which is basically the electron that you generated in the valence band, conduction band, and the hole that you generated in the conduction band, valence band, basically will react with the oxygen to create this highly active oxygen species. So this highly active oxygen species will react with any contaminants that you have in the system to demolarize them to make it less harmful. So basically, when you have aerobic system in the presence of oxygen, it involves water pollutants or dye degradation. But when we talk about hydrogen production, we require the reaction between electron and hole to conduct water reduction and water oxidation. And that's why in this case, it's very important for electron to be stabilized to make sure it can catalyze water splitting by reducing water into hydrogen. So in order to make it stabilize, we have to put some metal catalyst in it that will stabilize and increase the electron hole separation between the photogenerated carriers that we produce in the conduction band and in the valence band of titanium. So now we look at palladium titanium catalyst. There is an effect of metal loading when we look at palladium titanium catalyst, and then this is commonly known that for photocatalytic reaction, the lower the loading is much better for titanium because it will stop the light from penetrating to titanium bulk structure to generate electron holes. But what we're really interested is looking at the fundamental principle of palladium when activating the catalyst. So we have 0.5% palladium titanium, the black dot here, and also we have the high loading palladium titanium, the red square here at 5% palladium loading. Then we can see that 0.5% always has high rate of hydrogen production when we compare with the 5% palladium loading. And then we look at the first 50 minutes into the reaction, it's basically 5% palladium loading has this kind of induction period, which is it takes quite a while before the reactions take off and give you a steady rate of hydrogen production. So what we think about this, we call it as an induction period because when we're preparing our catalyst, palladium is always in the oxidized state. The palladium will be oxidized to get palladium oxide. Before palladium oxide can generate hydrogen through this reaction, it has to be reduced to palladium metal. How we know that? We carry out XPS analysis. XPS analysis is the surface sensitive technique that gives us information on the oxidation state of any element that we have at the surface, basically around a few nanometers above the surface of the catalyst. So we will know that when we have palladium titanium, most of the palladium exists as an oxidized state, which is palladium oxide. But on the post-reaction catalyst, we're starting to see palladium zero, combination between palladium 0 and palladium 2+, which is we see the reduction of palladium oxide into palladium metal during the catalytic activity. So what happened is palladium oxide was starting to reduce into palladium metal to get into palladium 0 before it can be sustainably produce hydrogen within the reaction condition. And in order to know whether this reaction, the induction thing happen or not, we can look at the thermodynamic activation energy of the catalyst by plotting the single plot of palladium titanium. And we know that it has minus 51.8 kilojoule per mole, which is, it tells us that the reducibility of palladium in this system is very likely to occur. And then we look at nickel titanium as a comparison, why nickel is less active than palladium titanium. That once again, we look at 0.5% nickel oxide and high loading of nickel oxide around 5%. And we can see that at 0.5, we give a tiny bit of hydrogen. It's not as good as palladium, but it's still active. But when we have 5% nickel oxide on titanium, the higher the loading, it gives less activity. And then we do the same thing with the activation energy. When we plot the activation energy of nickel oxide and titanium, we can see that it was positive 1, this is plus 1 for 1, which is a positive value, which is this is not happen naturally within the reaction condition. And one more again, when we look at nickel titanium post-reaction and nickel titanium catalyst XPS analysis, is basically there is no significant changes on the shift of the binding energy from nickel oxide into nickel metal. We know that what happened is nickel is very stable. It's not easy for nickel to be reduced, and therefore it won't not become the best co-catalyst for titanium for hydrogen production. Okay, but we can still work on nickel oxide. How to make nickel oxide, the unreactive nickel oxide, into much better activity? We can do that by creating nickel, because the thing with nickel, they are very unstable as nickel metal. It's very easy to oxidize to become nickel oxide. So we can create nickel at zero oxidation state underneath by creating metal oxide conservation layer on the surface. So basically, when we reduce them at 350 and then we slowly oxidize them with air, and then we manage to control the growth of the nickel oxide on the nickel oxide nanoparticle. And then what happened is we significantly inhibit the induction period and generate hydrogen at a lot more high rate. And when we do XPS analysis, we can still see some nickel oxide on the surface and also nickel chupas clearly observed, which means that we managed to reduce the barrier caused by this activation energy of nickel oxide and then make it more susceptible towards hydrogen production. And the same thing with when we look at all different of metal oxide, we can always look at all these kind of metal oxide and making an estimation how this metal oxide will actively react to generate hydrogen by looking at the enthalpy of reduction. And then what we have here, when we plot the enthalpy of hydrogen production over activation energy for every metal, and we can see that metal that has low activation energy will generate a lot more hydrogen compared to metal with have high activation energy. So it's all depending on how nickel or how this metal co-catalyst can be reduced within the environment to make sure it become an active catalyst for hydrogen production. We also try to look at different type of metal. We have platinum, gold, palladium, copper, rhodium, ruthenium, and iridium. And we also compare with nickel and iron oxide. Basically, this red dot line here tells us that all these metal co-catalysts within that have this negative enthalpy of reduction will behave a lot more active for hydrogen production in comparison to metal oxide that has positive value. I think a way to estimate whether this metal oxide will behave as a good co-catalyst or a worse co-catalyst for making hydrogen production. And then when we look at palladium titania, we can still do some experiment to increase the activity of palladium titania. And then the way to do it we try to understand the fundamental principle of palladium and how it can be used to control or to improve the hydrogen rate production. We try to look at palladium that we specifically tailored to have different particle size. We look at palladium at, we synthesize palladium at 1 degree Celsius, and then we increase the synthesis temperature from 1 degree to 25 degree, 50 and 75 degree. And when we look at TEM analysis, we managed to control the distribution of palladium. This is, we produce palladium at much narrow diameter, around 2.2 nanometers. And then when we increase the temperature, into a large size up to 8 nanometers when we go to and how this effect on the size of palladium translate into its activity. So when we plot the rate of hydrogen, this is another example of understanding the local structure of palladium using results analysis. The exact analysis it's a combination of SRD and XPS. It gives us the whole idea about the structure of our catalyst. So what we have here, we got this palladium metallic palladium bond. This is basically the radius of palladium in principle. We managed to probe into the local structure of palladium. And then we have that here, when we synthesize catalyst at 1 degree Celsius, it gives you more much smaller particle size. So when we look at the calculation, the coordination number tells us that the smallest catalyst will have smallest coordination number. It basically well dispersed catalyst. So when we look at hydrogen production, the catalyst that we produce at 1 degree Celsius is basically a lot more active than compared to catalysts that high in temperature. What happened is small catalysts which give us more interaction between titanium and palladium, so more electron can be transferred into palladium and give you more activity. But when you have this large palladium structure, it becomes a combination site. So it's no longer actively transferred into methanol and water to drive catalytic reaction, but instead it will be become a combination center to for electron and hole together to make it turn into heat. So when we compare palladium titania at similar loading but has different particle size, we can see that basically the smaller particle will give you more hydrogen. But when we have palladium titanium at different loading, but we manage to control the particle size about similar, basically have similar activity. So the idea from this research is saying that it doesn't really matter the amount of loading of palladium that you put in. What is important is how we control the particle size of palladium to make sure it gets into the smallest particle size to increase the interfacial interaction between palladium and titanium. So, and then, And another part of studies, we look at different type of alcohol that can be used. I mean, we try to produce hydrogen from different type of biofuels. We use methanol, ethanol, butanol, and from the product that we got, we come up with the rule of prediction that tells us when we look at this certain biofuel, how it will involve in hydrogen production. So we have this rule that's saying that basically all alcohol, it can be used to generate hydrogen, but it depends on the number of hydrogen. And only the alcohol will contribute to the hydrogen production, but the rest of the hydrogen, basically the one that we attach to the methyl group or alkyl group, will not be involved in hydrogen production. So this gives us some indication. When we look at some kind of biofuel molecule, we can predict them whether this will be active into generating hydrogen in photocatalytic condition. So basically, as a conclusion, we look at the flexibility of the band center of hydrogen, which is not that all and then need to be in zero oxidation states. So it's very important to make sure nickel or any metal for catalyst, they must be in zero oxidation state. If you can also improve the activity by reduce them in situ before the catalytic reaction in order to make sure it's much more active for the environment, for hydrogen production. So the interesting about precious metal is it actually is stable in this reduction zero oxidation state. So therefore, it can be used directly for hydrogen production. But when we're dealing with non-precious metal catalysts, we have to make sure it must be stable, or maybe do some pre-treatment that reduce them before it can be actively produce hydrogen in the reaction condition. So when we look at increasing palladium weight loading, basically we also affect the palladium intrinsic structure. So palladium intrinsic structure is very important because it's the one that provides electron sink for electron to be transformed from titanium into palladium. So we have to be very careful when we're changing variation of loading because it does not necessarily improve the activity, but it affects the palladium electronic structure to become the recombination site for electron and hole. So thank you very much. I think I used my 20 minutes just nicely. So thank you very much.
You're welcome, Dr. Hazli Al-Bahruzi. Yeah, very interesting speak. Yeah, very interesting speaks where it's very well connected to the previous center, water to hydrogen.
Thank you.
Okay, we move to our question and answer. We have on the chat room, there is some questions. The first is the question from Professor Diponegoro from our university. The question is directed to Professor Zuhairi in regard to how selective the production of mono D and 3-glycerol from the glycerol using this catalyst, and how the separation between these three to obtain the pure product before further use. Maybe Professor Zuhairi, you can answer the question first before we proceed with the next question.
Okay, thank you very much, Professor Andre.
Yes, you're welcome.
Okay, basically, when we talk about selectivity, right? In a chemical reaction, especially the chemical reaction involving a series of multiple steps of a reaction, usually we need to use the right type of catalyst to really direct the reaction towards the desired products, right? And this is actually common when it comes to the oleochemical reaction because in this type of reaction, usually many reaction steps will occur. Okay, because they are similar in nature, because they are just eterification reaction involving the reaction between glycerol with the removal of one water molecules. So here, the key to the solution is the use of the right type of catalyst, right? That is the first thing, right? So if we have a catalyst which is sufficiently active, but at the same time selective, we may end up with the most formation of the desired product. In this particular case, it is diglycerol. Okay, so definitely the reaction involve the right type of catalyst is desirable. It is needed. Okay, that is the first thing. Another thing is we need to really carry out the reaction in the suitable reaction conditions, consisting of the temperature, consisting of the catalyst amount, consisting of the probably the concentration of the reactant, right? So there is another solution there. It is actually need to be optimized so that we can get the most of the diglycerol rather than triglycerol rather than some other oligomers, right? So basically the key to the solution relies very much on the use of the right type of catalyst, and another one is the suitable reaction conditions, right? And when come to the question number 2, which is on the separation of the product, okay, it is actually a very difficult task there, right? Because the molecule could be similar, right? The molecule could be similar when it comes to the functional group of the molecule. Basically, they are all similar. The only thing is probably the length of the molecule could be different, right? So the idea here is glycerol is a liquid, right? When it comes to the oligomers, when it comes to the, for example, diglycerol, it is now becomes viscous solid, right? When it goes to the triglycerol, it becomes semi-solid already, right? So here we can use the principle of phase separation, okay, for the separation of the different components, right? So molecular dissolution can be used. The use of different temperature to segregate the molecule can be used, but of course it's not 100%. Okay, it's not 100%. So the idea here is, if it is possible to produce the highest possible diglycerol, it will be better, it will be good, it will be ideal, but it is always not achievable, right? But in the in reality, in the industry, probably we don't need to use pure diglycerol for this application, for the application of diglycerol. Basically, some amount of triglycerol could be allowable. Okay, could be allowable, and for the separation could be very expensive. Okay, so usually that could be my answer. Okay, for when it comes to the separations of the diglycerol molecules.
Due to the similarity and which trigger the difficulty in the separation. So the most important thing is how to produce high diglycerol compared to the other products. Okay, thank you. I move to the second question. Is directed to Professor Newman. This is the question come from this is your fellow Balinese from Dr. Putu Dodi Sutrisna from the Chemical Engineering Department, University Surabaya. He asked you, how did you do you have any experience on brine disposal treatment from SWRO or BWRO, and do you have any comments on experiences on the use of membrane distillation for zero liquid discharge seawater desalination? So I think it's better for Prof. Newman to share to the other audience.
Okay, thank you, Prof. Andri.
Yes.
I don't have experience in membrane distillation application, but I think the application of membrane distillation or membrane crystallization for brine water discharge is interesting to further investigate it, because the technology have a big potential to produce high-grade salt in application for industrial purposes. Okay, thank you.
Welcome. This is still another question from our previous students. We have Dr. Yanti. She's coming from Polytechnic Negeri Malang. She asked a very interesting question. What is the difference between the membrane that you made and the membrane that is commonly used in the water treatment in industry?
Okay. I don't prepare membrane, but I have worked in design and troubleshooting in operation. In our design, use combine between commercial available membrane and local membrane produced from GDV filter in Bandung. For local membrane available in ultrafiltration, but we cannot find the membrane of electrodialysis, reverse osmosis. If you need related to membrane ultrafiltration, you can get locally.
Okay, well, thank you very much, Prof. Newman. Still in the membrane, we have another question from the Indriana from Universitas Gadjah Mada. She's very thankful to your speech, and he has a question in regard to your experience in the membrane falling in your reactor. Should you have, and what should be done if you got such problems, and how did you cope this falling problem in your membrane so far?
Okay, the first step to control of membrane falling is the membrane selection, material, membrane structure, and module configuration. The second step is design. How we can design to pre-treatment of the membrane system. And finally, we must know how to clean the membrane by chemical cleaning. This is a three-step to cope membrane fouling. Membrane fouling does not be delayed, but we can control of the membrane fouling. If we can control the fouling of membrane, can find economic point of view of the membrane application.
Okay, thank you. So basically, the first thing to consider is that we choose the best membrane before we use.
Yes.
Okay. Hi, Dr. Hazliza, it's a question for you. How's Brunei today? Hopefully it's very good weather. Here in Semarang, also very good weather.
It's been raining for a month now in Brunei.
Okay, it's started raining here as well. Yeah, it's started raining here in Semarang. We have a question from our colleagues here in the department. In regard to the prospect of the use of the titania in the production of hydrogen, she said, as we know, that for the catalysis system has been developed since 1970s. And how long we should wait for this technology to be implemented in the large-scale hydrogen production? Because we know our fossil fuel reserve has been depleted for maybe the reserve is very, very little. So we will rely on hydrogen maybe in the future. So we welcome you and your research group to produce more and more hydrogen in the large scale later. As well, we are in Semarang as well. We love to be working together with you. So
yeah.
Okay.
It's a very tough question to us to answer, to be honest, because it's basically not us as a scientist who decide whether this should be, because changing from fossil fuels into green energy, it should be a world basically decision led by the leaders. So once there is a policy that tells us that we have to stop relying on fossil fuel and everything must be green, then when there's kind of rule, then when this thing should take place. One thing that we have to remember about photocatalytic reduction, hydrogen generation for photocatalysis, is a very low production when we compare them with steam reforming. And I just showed that and steam reforming occur at 1200 Kelvin and high pressure. basically the amount of hydrogen that you generate is a lot more higher than photocatalytic reaction. So in principle, photocatalytic is still in its infancy. It's not really not really guarantee you the amount of hydrogen that being generated as what they have done in industry. But when there is a policy that's saying we have to control hydrogen production, we have to control energy consumption from fossil fuel, but converted into completely green energy, that's I think when this method can starting to take off. That's my opinion.
Okay, yeah, it's correct. Even here in Indonesia, it was a big deal to change from wood, and then we changed to liquid petroleum gases in our daily life as well. It was a big deal to the government as well.
Yes.
Okay, so we are looking forward to how to create
hopefully
and to make a change, the world paradigm to change from fossil fuel to this green technology.
Yeah, hopefully.
Okay,
yes.
yeah, we are waiting for that. We have more question to you.
Yeah, sure.
This is from Vida Udaiba. She didn't mention from which institution she is coming from, and we greet you with very interesting presentation, of course. And you want to ask that the first, how much maximum the percentage of the metal drop to the titania to result height of hydrogen production? And then, okay, maybe that you first before proceed with the next question. How much the maximum percentage of the metal drop into the titania?
Yeah, I can see the question. Okay, the first question asking about metal loading. So basically, we have done some experiment to try to look at very low loading, 0.01% up to 1%, and we see that the optimum is around 0.5%. This is where it's the highest. And when the relationship between metal loading and activity is basically, you need to have metal to increase the electron hole separation. But if you put too much metal, it will starting to cover the surface of titanium. So what happened is it won't let the light get into titanium, so that it basically shield the titanium from accepting photon from light. So you have, if it's very, very low, it won't be as efficient. So the optimum from my experience is from the research that we have done is 0.5% loading, that's true. And one more thing, how the method of synthesizing nanoparticle will affect the activity. So we have looked at different type of method to generate palladium. We use incipient wetness impregnation method, which is we put palladium in a very controlled amount of water. And then we also use this deposition precipitation methods, which is we have loads of water, and then we filter them. And then also we have this salt immobilization method. The salt immobilization method, basically methods that we use to control the size of palladium nanoparticles. So all these three methods, it has different activity. So when we do some more analysis to understand why this method have a different, produce catalysts with different activity, the answer is the amount of palladium that actually been deposited. So when we have incipient impregnation method, we actually reduce the chance of palladium being, not being actually absorbed on the titanium surface. That's one thing. And if you use a method that has lots of fancy ligand, for example, salt immobilization method that we control the particle size, when we have these carbon deposits on the catalyst in this kind of ligand or ion, it will cause extra recombination center of the catalyst. It won't making the catalyst as active as what we hope for. So the best method for depositing palladium is incipient wetness impregnation. You control the amount of water, you make sure palladium actually absorb on the surface 100% instead of covered them with organic ligand or some ionic impurities that can affect the activity. So yeah, thank you.
Okay, great. One more thing that I want to see, just based on your experience, will be only very little metal that you added to the titanium, which is, I think, when you compare between 0.5 and 5%, 0.5 exhibited a better performance rather than the higher percentage. So how do we control the addition of this metal? And then the second one, I didn't see how's the quality of the water that you use for the production of this hydrogen from water splitting.
Okay, the quality and also okay. So
yep.
It's very difficult to precisely control particle size of palladium. That is true. It's very difficult, especially when we're dealing with the high loading of palladium. So what we did is basically we control the temperature of the colloidal solution. So this is specifically, like I said, colloidal solution is not the most efficient way to making the high active catalyst, but it gives us tools to controlling palladium on the titanium. What we did is we reduced the temperature of the synthesis process, which is we create palladium sol, which is palladium solution with sodium borohydride solution, and then also we're using PVA as a ligand, as a stabilizer. And then what happened is this will under 1 degree Celsius, we're starting at 1 degree Celsius. It's basically you reduce the kinetic of the metal. So basically at 1 degree, it won't active at 75 degree. So the deposition on the titanium will occur really slowly compared to at high temperature. So when we reduce the dissolution, the temperature of the solution, it will slowly deposit palladium nanoparticles onto titanium. That's how you control them. But to say that when you do 1 degree Celsius, you will get this size of palladium is not, we cannot say that. But what we can say, when we control the temperature, basically you're starting to increase the growth of palladium on titanium. That's how you can give a different variation of palladium size on titanium. That's how we got palladium at different particle size. And then how this affect hydrogen production? Basically, when we have much smaller particle size, let's say we take 0.1 gram of palladium loading. So with similar amount of palladium loading, but we increase the dispersion. Basically, you create much more surface interaction between palladium and titanium. So when you create much more palladium and titanium interfacial interaction, so basically you produce more sites for electron on the titanium to be converted or injected into palladium. That's why when we increase the dispersion, we increase kinetic activity of hydrogen production. Yeah, that's all. Thank you.
Yeah, I have the question. How's the purity of the water that we have to use?
Oh, the quality of water. Sorry.
Hydrogen.
Yeah. The quality of water at the moment we're using distilled water or deionized water. Okay. If you use tap water, pipe water, some tap water it has high concentration of minerals. These minerals will somehow activate your catalyst. So that is the limitation, I would say. So you need to have clean water to make sure it works. Yeah.
Okay. Yeah. So we should have a very high quality water.
Well, it's not high quality.
Okay, thank you.
The ionized water is still enough. You don't need high quality, top-notch water. No, it's just like distilled water. Basically, as much as distilled minerals, water. You cannot use seawater, obviously, but yeah, water that is being demineralized. Yeah.
Yeah. Okay. So the ionized might be the better, I think.
Yeah, the ionized water is best.
Sure. Yeah, because no interference with other minerals. Okay, I'm back to Professor Zuhairi. I have a question to you. In the beginning of your presentation, you said the glycerol can be converted not only to mono D and glycerol, but it can be also converted into polyester and then acrylate as well the polyether. Have you done any experience to produce all these three products that you mentioned before?
Okay, thank you for the question. Yeah, we have done some work on the production of esters, and I was also involved in the project involving the use of glycerol to produce glycerol carbonate. And currently, I'm also involved in the production of acrolein. Right, but definitely, acrolein is not the desired product in our reaction. We want something else. But acrolein is actually needed for the as an intermediate, okay, for the formation of lactic acid. We want lactic acid, but acrolein is actually produced as an intermediate upon the dehydration of glycerol, right? So basically, as shown in my slide, okay, as shown in my slide during my presentation, because of the functionality of the molecule, because one molecule of glycerol contains 3 OH group, right? And we know that OH group is quite active for the interaction with some other molecules. So because of that, we have 3 different chances of interaction between glycerol and other molecule, and also between glycerol and another glycerol molecule. So because of that, we have basically unlimited opportunity to create some value-added chemicals from glycerol, right? And in the slide that I showed to you just now in this morning, there are some products, value-added products that can be generated, but this actually not limited to only these chemicals. Basically, there are many more, right? Because of the functionality of the molecule.
Yeah.
So, but definitely, I used to be involved in some other reaction involving glycerol, esterification, esterification, dehydration, and yeah, another type of esterification, because esterification is actually involving glycerol and some other molecule, and we can change another molecule to a different molecule depending on the desired product that we need, because esterification is actually a group of reaction involving glycerol and some other molecules. But definitely those things are within my research interest, and actually I have been involved in this since the last 10 years. So definitely yeah, I learned something here to be shared with other people, and just in case you are also interested to venture into this particular research area, so by all means please proceed, because it's very interesting to discover that.
Sure, that's very interesting work. And one more question from me. We are here in the department. We developed a catalyst coming from eggshell to provide the calcium. So it is possible to use the eggshell as the source of calcium that you prepare for the CA and LA in combination with the MCM41 for this catalyst that you developed in your department?
Yeah, in our study, basically in this reaction, definitely CA can perform as a catalyst, because CA has sufficient level of basicity to be actively involved in this reaction. But not only that, okay, not only, we have to be careful, because if the catalyst is active, it may be active in synthesizing, in producing diglycerol, but the same catalyst can also perform another step of reaction to form triglycerol, which is undesired, right? So because of that, active catalyst alone doesn't really serve the purpose. We want to have something else. We want to have the suitable type of support that can actually play a role in dictating the reaction towards the desired product. This is important, right? Because a good catalyst will definitely form oligomer, glycerol oligomers rather than mono, rather than diglycerol or triglycerol. Something else, because of the catalyst is actually active. So because of that, the reaction can progress one step after another to form di, tri, and so on. So because of that, we may end up with something undesirable rather than the diglycerol that we need from this reaction. So the support play a equally important role to dictate the direction towards the desired product, which is diglycerol, right? Active catalyst is needed, but also at the same time selective. Needs to be selective.
Yep.
Yeah.
Okay, Professor Zuari, our department is currently considered as one of the leading researchers in the field of palm oil conversion into biodiesel, and we produce as well glycerol of our side product. So we are happy to be with you here. And actually, we are proceed with the research on the biohydrogen production. So if we have a very good opportunity in the future, maybe we can join together and work together to produce this product, and as well the development of the catalyst that you and your team and your department are currently working as well.
Yeah. Good. It's very interesting, but definitely I would love to be involved in your research project as well. But of course, we are looking forward to have future collaboration, just in case there's any. Inshallah.
Sure. We are happy to your defense Malaysia.
Yeah.
Okay, back to Dr. Hasliza. We have another question from the audience here. From Adriana Kartini. This is from Universitas Gadjah Mada as well. She asks you, did you use palladium alkoxide, did you use palladium alkoxide as the precursor for colloidal preparation of the palladium and titania? Because in Indonesia, it is quite hard to get this alkoxide precursor.
No, I'm not using palladium alkoxide. I'm using. Hello. Okay. I'm using K2PDCl4, which is potassium chloropalladinate. So basically, it doesn't really matter what precursor that you use. It doesn't really matter at all. What important is it can be dissolved or not, because palladium is quite difficult to dissolve. You probably need to put some acid and sonicated them for quite a long time to make it dissolve. The only salt precursor that can be easily dissolved is K2PDCl4. But what my suggestion for you, if you want to do photocatalytic water splitting, probably you have to start moving from palladium to different precursor, because palladium is starting to get really expensive at the moment, because the price of palladium is getting crazily expensive. It's even more expensive than platinum. So if you want to work on precious metal, you can start looking at silver. Silver also has good activity. And also, if you want to go to cheaper alternative, you can look at copper. And also, copper is quite interesting. You can still start working with copper, which is a lot more cheaper than palladium. So yeah, palladium is very expensive. I'm actually starting to move from palladium, which is, there is no, when we talk about catalytic practice in industry, they always look at cheaper alternative. To have palladium as your catalyst, probably not a viable approach to making it more sustainable in the industry. That's what I would say. Yep.
Okay, well, it's correct that, of course, for commercial and industrial scale, we are always looking for a cheaper raw materials so that we can result in a higher profit. This is another question from the audience, from Vida Odaiba. She asks you, longer organic sacrificial agent result methane product. How to reduce this product, and how about the design of the catalyst that give low selectivity to methane but high selectivity to hydrogens?
Okay, I'm sorry, I kind of like skip the last slide because I don't want to use up other people's times. But methane actually produced when you have alcohol with alkyl group in the system. Basically, if you have methanol, basically you have alpha hydrogen, and then 3 alpha hydrogen and 1 hydroxyl group. Basically, all the hydrogen in methanol will be used up to generate hydrogen gas. That's not a problem for methanol. But when you're starting to increase the number of carbon of your alcohol, for example, you start with ethanol, and then you go to propanol. So you have this alkyl group that attached to your carbonyl, which you have CO, carbon oxide. And then you also have this alkyl group for methyl group. This methyl group, instead of making hydrogen, it cannot be decomposed under photocatalytic condition. So this methyl group will instead recombine with hydrogen and generate methane. So from what we understand at the moment, we couldn't decompose this methane group further into generating into hydrogen. So methane is always there. So we have to find a way to decompose methane to generate hydrogen, which is at the moment we don't have answer for that. Yep.
Okay, thank you, Dr. Aliza. I think we have a very long discussion here, so we are still waiting for the audience actually to have a question. We still have 1 or 2 minutes for the question and answer. So let to Professor Newman. I have a question here. Hello, Prof. Newman, are you still online?
Hello, Prof. Andri.
Okay, great. I still have a question to you in regard to how your work with the membrane to reduce the total dissolved solid, and then the chlorine and the silica that you mentioned in your presentation. These 3 components in the wastewater being unsuccessful when your previous in your previous work. Do you have any idea how to solve this problem?
Can you repeat your question?
Yes. I check back on your presentation that you have problems and solving how to reduce the total dissolved solid and then the chlorine as well as the silica content on the wastewater to meet the water quality before being used for further process or maybe for consumption. So do you have any idea how actually to solve this problem in your future work?
Okay, to remove dissolved solid like silica, chloride, and total dissolved solid, we just have one choice. This is the use of RO membrane. Yeah, we cannot use the porous membrane. Yeah, maybe in other choice, electrodialysis or electrodeionation, but the 2 process is more expensive compared to RO system.
Okay, thank you. So we're back to the reverse osmosis. Yeah. Okay. I think we have a very long discussion so far, starting from 9:30, and now it's already 11:20 here in Jakarta time. So before I close this session, I would like to thank Professor Dr. Tan Sri Zuhairi, and then also to Dr. Aziza Baruji from UT Brunei Darussalam. And of course, our beloved Professor Newman Widiasa. Thank you very much for your presentation and nice discussion with us and also with all the audience. And hopefully we will proceed with our collaborative work in the future. And thank you very much for joining us in this international conference on chemical and material engineering 2020. As the moderator for this first plenary session, I apologize for any inconvenience caused, and thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much for the invitation.
You're
Nice.
welcome.
Nice session. Thank you.
Yes, thank you.
All right, thank you very much for the excellent lectures. The first plenary session is ended, and we will continue for the next plenary session by 12:30 Jakarta time. So stay tuned in the Zoom and YouTube live of the 4th International Conference on Chemical and Materials Engineering, ICCME 2020.
Assalamualaikum warahmatullahi Assalamualaikum warahmatullahi wabarakatuh. Hai Sobat Bijak, tahukah Sobat, ada berbagai jenis investasi, diantaranya Assalamualaikum warahmatullahi wabarakatuh. Hai Sobat Bijak, tahukah Sobat, ada berbagai jenis investasi, diantaranya properti, saham, reksadana, tanah, emas, dan lainnya. Kali ini kita akan membahas tentang investasi emas. Saat ini, emas bukan sekedar perhiasan semata, namun juga investasi yang paling stabil terhadap inflasi, mudah diuangkan, mudah disimpan, dan mudah dibawa. Yuk, saatnya kita rencanakan finansial masa depan dengan berinvestasi emas bersama tabungan emas Pegadaian Syariah. Tabungan emas Pegadaian Syariah adalah layanan penitipan saldo emas yang memudahkan masyarakat untuk berinvestasi emas. Jangan khawatir, Pegadaian Syariah menjamin ketersediaan fisik emas yang kalian tabungkan. Dapat diakses online melalui aplikasi Pegadaian Syariah Digital atau datang langsung ke lebih dari 600 outlet Pegadaian Syariah di seluruh Indonesia serta agen Pegadaian Syariah. Apakah Sobat Bijak tahu, harga pembelian emas mulai dari ribuan rupiah saja dan terjamin kemurnian fisik emasnya. Soal keamanannya tak perlu diragukan lagi. PT Pegadaian merupakan BUMN yang berpengalaman serta diawasi oleh Otoritas Jasa Keuangan. Tabungan emas Pegadaian Syariah sudah sesuai dengan Fatwa Dewan Syariah Nasional Majelis Ulama Indonesia nomor 04/DSN strip MUI _4 Romawi _2000 tentang murabahah dan nomor 77/DSN strip MUI _5 Romawi _2000 tentang murabahah emas. Sobat bijak, tabungan emas Pegadaian Syariah ini bisa dijual kembali, bisa dicetak menjadi emas batangan, maupun ditransfer antar rekening. Tidak hanya itu, tabungan emas di Pegadaian Syariah bisa dijadikan sebagai barang jaminan rahen atau gadai loh. Ada 3 cara pembukaan rekening melalui lebih dari 600 outlet Pegadaian Syariah dan lebih dari 4.000 agen Pegadaian Syariah atau melalui aplikasi Pegadaian Syariah Digital. Pilih menu buka tabungan, masukkan nominal pembukaan tabungan dalam rupiah, tekan tombol konversi untuk mengonversikan nominal dalam bentuk gram emas, lengkapi data nasabah apabila belum dilengkapi, pilih cabang lokasi pembukaan rekening, pilih metode pembayaran dan lakukan pembayaran. Selanjutnya, buku tabungan dapat diambil di cabang pendaftaran yang kamu pilih. Simple banget kan caranya? Jangan lupa untuk aktivasi finansial di cabang ya, agar kamu lebih mudah mengakses fitur-fitur menarik dari Pegadaian Syariah Digital. Mudah kan? Yuk mulai nabung emas di Pegadaian Syariah. Tabungan emas Pegadaian Syariah, tepat caranya, berkah hasilnya.
Diponegoro University has been moving ahead to be the best university in Indonesia by providing 13 faculties of undergraduate and postgraduate. Diponegoro University has graduated 300,000 qualified alumnus. Diponegoro University also establishes vocational schools to generate a ready-to-work alumnus. Holding the fighting values of Pangaran Diponegoro, such as honest, brave, fair and attentive, Diponegoro University keeps producing excellent alumnus nationally and internationally, while also contributing in the development of knowledge, technology, art, culture and exercise.
Diponegoro University now is a rising star. We have planned to become one of university in 500 world university rank. We have been continuously improving the supporting aspect such as regulation, facilities, financial system, bureaucracy management, information system, as well as quality of human resources, quality escalation of three Dharma perguruan tinggi is the primary target of UNDIP by stimulating the downstream of research outcomes that can be beneficially implemented for the society. We are also keen to improve the quantity of national and international academic publication, as well as the number of doctorates and professors in Diponegoro University.
Now, Diponegoro University has been improving in two important aspects of achievement: institutionally and student achievement. Diponegoro University has become a world-class university by being ranked 5th amongst almost 5,000 universities in Indonesia. Meanwhile, the students' achievement in both national and international scales of prestigious events are increasing. The vision to be an eminent research university is supported by the continued increase of research funding. The total research and civil service funding in 2018 is 123.7 billion rupiah. It consists of PNBP, the National Competition Research Funding, and Collaboration Research Funding. The intellectual property right becomes the indicator of significantly improved research. The patent consists of simple patent, patent, international patent, software, and invention legal letter. To support the academic process, Diponegoro University has been improving the student facilities. Thus, the students will not only get the knowledge, but also the actualization space. The academic service, Diponegoro University has built a central computerized system that includes the service for the online study plan and online registration.
Iklim kompetisi di Undip yang sportif dan konstruktif memacu saya untuk terus berprestasi dalam akademik maupun non-akademik.
Didukung dengan fasilitas umum dan keakademikan yang lengkap.
Sehingga membawa Undip masuk 10 besar universitas terbaik di Indonesia.
Undip berada di daerah beragam budaya yang harmonis.
Yang pastinya Undip lebih baik.
Undip lebih baik. Bagaimanapun, Undip pasti lebih baik.
Masa apa, weh?
Pak Hantoro.
Assalamualaikum warahmatullahi wabarakatuh. Hai Sobat Bijak, tahukah Sobat, ada berbagai jenis investasi, diantaranya properti, saham, reksadana, tanah, emas, dan lainnya. Kali ini kita akan membahas tentang investasi emas. Saat ini, emas bukan sekedar perhiasan semata, namun juga investasi yang paling stabil terhadap inflasi, mudah diuangkan, mudah disimpan, dan mudah dibawa. Yuk, saatnya kita rencanakan finansial masa depan dengan berinvestasi emas bersama tabungan emas Pegadaian Syariah. Tabungan emas Pegadaian Syariah adalah layanan penitipan saldo emas yang memudahkan masyarakat untuk berinvestasi emas. Jangan khawatir, Pegadaian Syariah menjamin ketersediaan fisik emas yang kalian tabungkan. Dapat diakses online melalui aplikasi Pegadaian Syariah Digital atau datang langsung ke lebih dari 600 outlet Pegadaian Syariah di seluruh Indonesia serta agen Pegadaian Syariah. Apakah Sobat Bijak tahu? Harga pembelian emas mulai dari ribuan rupiah saja dan terjamin kemurnian fisik emasnya. Soal keamanannya tak perlu diragukan lagi. PT Pegadaian merupakan BUMN yang berpengalaman serta diawasi oleh Otoritas Jasa Keuangan. Tabungan emas Pegadaian Syariah sudah sesuai dengan Fatwa Dewan Syariah Nasional Majelis Ulama Indonesia nomor 04/DSN /MUI /4-Romawi/2000 tentang murabaha dan nomor 77/DSN /MUI/5-Romawi/2000 tentang murabaha emas. Sobat Bijak, tabungan emas Pegadaian Syariah ini bisa dijual kembali, bisa dicetak menjadi emas batangan, maupun ditransfer antar rekening. Tidak hanya itu, tabungan emas di Pegadaian Syariah bisa dijadikan sebagai barang jaminan rahn atau gadai loh. Ada 3 cara pembukaan rekening melalui lebih dari 600 outlet Pegadaian Syariah dan lebih dari 4.000 agen Pegadaian Syariah atau melalui aplikasi Pegadaian Syariah Digital. Pilih menu buka tabungan, masukkan nominal pembukaan tabungan dalam rupiah, tekan tombol konversi untuk mengonversikan nominal dalam bentuk gram emas, lengkapi data nasabah apabila belum dilengkapi, pilih cabang lokasi pembukaan rekening, pilih metode pembayaran dan lakukan pembayaran. Selanjutnya, buku tabungan dapat diambil di cabang pendaftaran yang kamu pilih. Simple banget kan caranya? Jangan lupa untuk aktivasi finansial di cabang ya, agar kamu lebih mudah mengakses fitur-fitur menarik dari Pegadaian Syariah Digital. Mudah kan? Yuk mulai nabung emas di Pegadaian Syariah. tabungan Mas Pegadaian Syariah, tepat caranya, berkah hasilnya.
Diponegoro University has been moving ahead to be the best university in Indonesia by providing 13 faculties of undergraduate and postgraduate. Diponegoro University has graduated 300,000 qualified alumnus. Diponegoro University also establishes vocational schools to generate a ready-to-work alumnus. Holding the fighting values of Pangaran Diponegoro, such as honest, brave, fair and attentive, Diponegoro University keeps producing excellent alumnus nationally and internationally, while also contributing in the development of knowledge, technology, art, culture and exercise.
Diponegoro University now is a rising star. We have planned to become one of university in 500 world university rank. We have been continuously improving the supporting aspect such as regulation, facilities, financial system, bureaucracy management, information system, as well as quality of human resources, quality escalation of three Dharma perguruan tinggi is the primary target of UNDIP by stimulating the downstream of research outcomes that can be beneficially implemented for the society. We are also keen to improve the quantity of national and international academic publication, as well as the number of doctorates and professors in Diponegoro University.
Now, Diponegoro University has been improving in two important aspects of achievement: institutionally and student achievement. Diponegoro University has become a world-class university by being ranked 5th amongst almost 5,000 universities in Indonesia. Meanwhile, the students' achievement in both national and international scales of prestigious events are increasing. The vision to be an eminent research university is supported by the continued increase of research funding. The total research and civil service funding in 2018 is 123.7 billion rupiah. It consists of PNBP, the National Competition Research Funding, and Collaboration Research Funding. The intellectual property right becomes the indicator of significantly improved research. The patent consists of simple patent, patent, international patent, software, and invention legal letter. To support the academic process, Diponegoro University has been improving the student facilities. Thus, the students will not only get the knowledge, but also the actualization space. For the academic service, Diponegoro University has built a central computerized system that includes the service for the online study plan and online registration.
Iklim kompetisi di Undip yang sportif dan konstruktif memacu saya untuk terus berprestasi dalam akademik maupun non-akademik.
Didukung dengan fasilitas umum dan keakademikan yang lengkap.
Sehingga membawa Undip masuk 10 besar universitas terbaik di Indonesia.
Undip berada di daerah beragam budaya yang harmonis.
Yang pastinya Undip lebih baik.
Undip lebih baik. Bagaimanapun, Undip pasti lebih baik.
Assalamualaikum warahmatullahi wabarakatuh. Hai Sobat Bijak, tahukah Sobat, ada berbagai jenis investasi, diantaranya properti, saham, reksadana, tanah, emas, dan lainnya. Kali ini kita akan membahas tentang investasi emas. Saat ini, emas bukan sekedar perhiasan semata, namun juga investasi yang paling stabil terhadap inflasi, mudah diuangkan, mudah disimpan, dan mudah dibawa. Yuk, saatnya kita rencanakan finansial masa depan dengan berinvestasi emas bersama tabungan emas Pegadaian Syariah. Tabungan emas Pegadaian Syariah adalah layanan penitipan saldo emas yang memudahkan masyarakat untuk berinvestasi emas. Jangan khawatir, Pegadaian Syariah menjamin ketersediaan fisik emas yang kalian tabungkan. Dapat diakses online melalui aplikasi Pegadaian Syariah Digital atau datang langsung ke lebih dari 600 outlet Pegadaian Syariah di seluruh Indonesia serta agen Pegadaian Syariah. Apakah Sobat Bijak tahu? Harga pembelian emas mulai dari ribuan rupiah saja dan terjamin kemurnian fisik emasnya. Soal keamanannya tak perlu diragukan lagi. PT Pegadaian merupakan BUMN yang berpengalaman serta diawasi oleh Otoritas Jasa Keuangan. Tabungan emas Pegadaian Syariah sudah sesuai dengan Fatwa Dewan Syariah Nasional Majelis Ulama Indonesia nomor 04/DSN strip MUI /4 Romawi /2000 tentang murabahah dan nomor 77/DSN strip MUI /5 Romawi /2000 tentang murabahah emas. Sobat bijak, tabungan emas Pegadaian Syariah ini bisa dijual kembali, bisa dicetak menjadi emas batangan, maupun ditransfer antar rekening. Tidak hanya itu, tabungan emas di Pegadaian Syariah bisa dijadikan sebagai barang jaminan rahen atau gadai loh. Ada 3 cara pembukaan rekening melalui lebih dari 600 outlet Pegadaian Syariah dan lebih dari 4.000 agen Pegadaian Syariah atau melalui aplikasi Pegadaian Syariah Digital. Pilih menu buka tabungan, masukkan nominal pembukaan tabungan dalam rupiah, tekan tombol konversi untuk mengonversikan nominal dalam bentuk graf emas, lengkapi data nasabah apabila belum dilengkapi, pilih cabang lokasi pembukaan rekening, pilih metode pembayaran dan lakukan pembayaran. Selanjutnya, buku tabungan dapat diambil di cabang pendaftaran yang kamu pilih. Simple banget kan caranya? Jangan lupa untuk aktivasi finansial di cabang ya, agar kamu lebih mudah mengakses fitur-fitur menarik dari Pegadaian Syariah Digital. Mudah kan? Yuk mulai nabung emas di Pegadaian Syariah. Tabungan emas Pegadaian Syariah, tepat caranya, berkah hasilnya.
Diponegoro University has been moving ahead to be the best university in Indonesia by providing 13 faculties of undergraduate and postgraduate. Diponegoro University has graduated 300,000 qualified alumnus. Diponegoro University also establishes vocational schools to generate a ready-to-work alumnus. Holding the fighting values of Pangaran Diponegoro, such as honest, brave, fair and attentive, Diponegoro University keeps producing excellent alumnus nationally and internationally, while also contributing in the development of knowledge, technology, art, culture and exercise.
Diponegoro University now is a rising star. We have planned to become one of university in 500 world university rank. We have been continuously improving the supporting aspect such as regulation, facilities, financial system, bureaucracy management, information system, as well as quality of human resources, quality escalation of three Dharma perguruan tinggi is the primary target of UNIP by stimulating the downstream of research outcomes that can be beneficially implemented for the society. We also keen to improve the quantity of national and international academic publication, as well as the number of doctorates and professors in Diponegoro University.
Now, Diponegoro University has been improving in two important aspects of achievement: institutionally and student achievement. Diponegoro University has become a world-class university by being ranked 5th amongst almost 5,000 universities in Indonesia. Meanwhile, the students' achievement in both national and international scales of prestigious events are increasing. The vision to be an eminent research university is supported by the continued increase of research funding. The total research and civil service funding in 2018 is 123.7 billion rupiah. It consists of PNBP, the National Competition Research Funding, and Collaboration Research Funding. The intellectual property right becomes the indicator of significantly improved research. The patent consists of simple patent, patent, international patent, software, and invention legal letter. To support the academic process, Diponegoro University has been improving the student facilities. Thus, the students will not only get the knowledge, but also the actualization space. Academic service, Diponegoro University has built a central computerized system that includes the service for the online study plan and online registration.
Kompetisi di Undip yang sportif dan konstruktif memacu saya untuk terus berprestasi dalam akademik maupun non-akademik.
Didukung dengan fasilitas umum dan keakademikan yang lengkap.
Sehingga membawa Undip masuk 10 besar universitas terbaik di Indonesia.
Undip berada di daerah beragam budaya yang harmonis.
Yang pastinya Undip lebih baik.
Undip lebih baik. Bagaimanapun, Undip pasti lebih baik.
Assalamualaikum warahmatullahi wabarakatuh. Hai Sobat Bijak, tahukah Sobat, ada berbagai jenis investasi, diantaranya properti, saham, reksadana, tanah, emas, dan lainnya. Kali ini kita akan membahas tentang investasi emas. Saat ini, emas bukan sekedar perhiasan semata, namun juga investasi yang paling stabil terhadap inflasi, mudah diuangkan, mudah disimpan, dan mudah dibawa. Yuk, saatnya kita rencanakan finansial masa depan dengan berinvestasi emas bersama tabungan emas Pegadaian Syariah. Tabungan emas Pegadaian Syariah adalah layanan penitipan saldo emas yang memudahkan masyarakat untuk berinvestasi emas. Jangan khawatir, Pegadaian Syariah menjamin ketersediaan fisik emas yang kalian tabungkan. Dapat diakses online melalui aplikasi Pegadaian Syariah digital atau datang langsung ke lebih dari 600 outlet Pegadaian Syariah di seluruh Indonesia serta agen Pegadaian Syariah. Apakah Sobat Bijak tahu, harga pembelian emas mulai dari ribuan rupiah saja dan terjamin kemurnian fisik emasnya. Soal keamanannya tak perlu diragukan lagi. PT Pegadaian merupakan BUMN yang berpengalaman serta diawasi oleh Otoritas Jasa Keuangan. Tabungan emas Pegadaian Syariah sudah sesuai dengan Fatwa Dewan Syariah Nasional Majelis Ulama Indonesia nomor 04/DSN /MUI /4-Romawi/2000 tentang murabaha dan nomor 77/DSN /MUI/5-Romawi/2000 tentang murabaha emas. Sobat Bijak, tabungan emas Pegadaian Syariah ini bisa dijual kembali, bisa dicetak menjadi emas batangan, maupun ditransfer antar rekening. Tidak hanya itu, tabungan emas di Pegadaian Syariah bisa dijadikan sebagai barang jaminan rahn atau gadai loh. Ada 3 cara pembukaan rekening melalui lebih dari 600 outlet Pegadaian Syariah dan lebih dari 4.000 agen Pegadaian Syariah atau melalui aplikasi Pegadaian Syariah digital. Pilih menu buka tabungan, masukkan nominal pembukaan tabungan dalam rupiah, tekan tombol konversi untuk mengonversikan nominal dalam bentuk graf emas, lengkapi data nasabah apabila belum dilengkapi, pilih cabang lokasi pembukaan rekening, pilih metode pembayaran dan lakukan pembayaran. Selanjutnya, buku tabungan dapat diambil di cabang pendaftaran yang kamu pilih. Simple banget kan caranya? Jangan lupa untuk aktivasi finansial di cabang ya, agar kamu lebih mudah mengakses fitur-fitur menarik dari Pegadaian Syariah digital. Mudah kan? Yuk mulai nabung emas di Pegadaian Syariah. Tabungan emas Pegadaian Syariah, tepat caranya, berkah hasilnya.
Diponegoro University has been moving ahead to be the best university in Indonesia by providing 13 faculties of undergraduate and postgraduate. Diponegoro University has graduated 300,000 qualified alumnus. Diponegoro University also establishes vocational schools to generate a ready-to-work alumnus. Holding the fighting values of Pangaran Diponegoro, such as honest, brave, fair and attentive, Diponegoro University keeps producing excellent alumnus nationally and internationally, while also contributing in the development of knowledge, technology, art, culture and exercise.
Diponegoro University now is a rising star. We have planned to become one of university in 500 world university rank. We have been continuously improving the supporting aspect such as regulation, facilities, financial system, bureaucracy management, information system, as well as quality of human resources, quality escalation of three Dharma perguruan tinggi is the primary target of UNDIP by stimulating the downstream of research outcomes that can be beneficially implemented for the society. We are also keen to improve the quantity of national and international academic publication, as well as the number of doctorates and professors in Diponegoro University.
Now, Diponegoro University has been improving in two important aspects of achievement: institutionally and student achievement. Diponegoro University has become a world-class university by being ranked 5th amongst almost 5,000 universities in India. Students' achievement in both national and international scales of prestigious events are increasing. The vision to be an eminent research university is supported by the continued increase of research funding. The total research and civil service funding in 2018 is 123.7 billion rupiah. It consists of PNBP, the National Competition Research Funding, and Collaboration Research Funding. The intellectual property right becomes the indicator of significantly improved research. The patent consists of simple patent, patent, international patent, software and invention legal letter. To support the academic process, Diponegoro University has been improving the student facilities. Thus, the students will not only get the knowledge but also the actualization space. For the academic service, Diponegoro University has built a central computerized system that includes the service for the online study plan and online registration.
Iklim kompetisi di Undip yang sportif dan konstruktif memacu saya untuk terus berprestasi dalam akademik maupun non-akademik.
Didukung dengan fasilitas umum dan keakademikan yang lengkap.
Sehingga membawa Undip masuk 10 besar universitas terbaik di Indonesia.
Undip berada di daerah beragam budaya yang harmonis.
Yang pastinya Undip lebih baik.
Undip lebih baik. Bagaimanapun, Undip pasti lebih baik.
Weapon
Assalamualaikum warahmatullahi wabarakatuh. Hai Sobat Bijak. Tahukah Sobat, ada berbagai jenis investasi, diantaranya properti, saham, reksadana, tanah, emas, dan lainnya. Kali ini kita akan membahas tentang investasi emas. Saat ini, emas bukan sekedar perhiasan semata, namun juga investasi yang paling stabil terhadap inflasi, mudah diuangkan, mudah disimpan, dan mudah dibawa. Yuk, saatnya kita rencanakan finansial masa depan dengan berinvestasi emas bersama tabungan emas Pegadaian Syariah. Tabungan emas Pegadaian Syariah adalah layanan penitipan saldo emas yang memudahkan masyarakat untuk berinvestasi emas. Jangan khawatir, Pegadaian Syariah menjamin ketersediaan fisik emas yang kalian tabungkan. Dapat diakses online melalui aplikasi Pegadaian Syariah digital atau datang langsung ke lebih dari 600 outlet Pegadaian Syariah di seluruh Indonesia serta agen Pegadaian Syariah. Apakah Sobat Bijak tahu? Harga pembelian emas mulai dari ribuan rupiah saja dan terjamin kemurnian fisik emasnya. Soal keamanannya tak perlu diragukan lagi. PT Pegadaian merupakan BUMN yang berpengalaman serta diawasi oleh Otoritas Jasa Keuangan. Tabungan emas Pegadaian Syariah sudah sesuai dengan Fatwa Dewan Syariah Nasional Majelis Ulama Indonesia nomor 04/DSN /MUI /4 Romawi /2000 tentang murabaha dan nomor 77/DSN /MUI /5 Romawi /2000 tentang murabaha emas. Sobat Bijak, tabungan emas Pegadaian Syariah ini bisa dijual kembali, bisa dicetak menjadi emas batangan, maupun ditransfer antar rekening. Tidak hanya itu, tabungan emas di Pegadaian Syariah bisa dijadikan sebagai barang jaminan rahn atau gadai loh. Ada 3 cara pembukaan rekening melalui lebih dari 600 outlet Pegadaian Syariah dan lebih dari 4.000 agen Pegadaian Syariah atau melalui aplikasi Pegadaian Syariah digital. Pilih menu buka tabungan, masukkan nominal pembukaan tabungan dalam rupiah, tekan tombol konversi untuk mengonversikan nominal dalam bentuk graf emas, lengkapi data nasabah apabila belum dilengkapi, pilih cabang lokasi pembukaan rekening, pilih metode pembayaran dan lakukan pembayaran. Selanjutnya, buku tabungan dapat diambil di cabang pendaftaran yang kamu pilih. Simple banget kan caranya? Jangan lupa untuk aktivasi finansial di cabang ya, agar kamu lebih mudah mengakses fitur-fitur menarik dari Pegadaian Syariah digital. Mudah kan? Yuk mulai nabung emas di Pegadaian Syariah. Tabungan emas Pegadaian Syariah, tepat caranya, berkah hasilnya.
Diponegoro University has been moving ahead to be the best university in Indonesia by providing 13 faculties of undergraduate and postgraduate. Diponegoro University has graduated 300,000 qualified alumnus. Diponegoro University also establishes vocational schools to generate a ready-to-work alumnus. Holding the fighting values of Pangaran Diponegoro, such as honest, brave, fair and attentive, Diponegoro University keeps producing excellent alumnus nationally and internationally, while also contributing in the development of knowledge, technology, art, culture and exercise.
Diponegoro University now is a rising star. We have planned to become one of university in 500 world university rank. We have been continuously improving the supporting aspect such as regulation, facilities, financial system, bureaucracy management, information system, as well as quality of human resources, quality escalation of three Dharma perguruan tinggi. As the primary target of UNDIP, by stimulating the downstream of research outcomes that can be beneficially implemented for the society. We also keen to improve the quantity of national and international academic publication, as well as the number of doctorates and professors in Diponegoro University.
Now, Diponegoro University has been improving in two important aspects of achievement: institutionally and student achievement. Diponegoro University has become a world-class university by being ranked 5th amongst almost 5,000 universities in Indonesia. Meanwhile, the students' achievement in both national and international scales of prestigious events are increasing. The vision to be an eminent research university is supported by the continued increase of research funding. The total research and civil service funding in 2018 is 123.7 billion rupiah. It consists of PNBP, the National Competition Research Funding, and Collaboration Research Funding. The intellectual property right becomes the indicator of significantly improved research. The patent consists of simple patent, patent, international patent, software and invention legal letter. To support the academic process, Diponegoro University has been improving the student facilities. Thus, the students will not only get the knowledge but also the actualization space. The academic service, Diponegoro University has built a central computerized system that includes the service for the online study plan and online registration.
sportif dan konstruktif memacu saya untuk terus berprestasi dalam akademik maupun non-akademik.
Didukung dengan fasilitas umum dan keakademikan yang lengkap.
Sehingga membawa Undip masuk 10 besar universitas terbaik di Indonesia.
Undip berada di daerah, beragam budaya yang harmonis.
Yang pastinya Undip lebih baik.
Undip lebih baik. Bagaimanapun, Undip pasti lebih baik.
Good afternoon, and we hope you have a good break.
We are delighted to welcome you back to the second session of plenary lectures of the 4th International Conference on Chemical and Materials Engineering, ICCME 2020.
Ladies and gentlemen, we will soon continue with the plenary session 2. Thus, please have a seat and make yourself comfortable. We kindly remind you one more time to mute your microphone to ensure that this event runs smoothly.
Ladies and gentlemen, we will now begin the plenary session 2, followed by an interactive discussion.
Our remarkable speakers will present the plenary lecture.
The first is David Mwinfo, Doctor of Philosophy, Director Center of Excellence for Green Energy and Environmental Nanomaterials, CE at Green, from Nguyen Tat Thanh University, Vietnam.
The second is Dr. Insinyur Harsawardana, Master of Engineering, Indonesian Sustainable Palm Oil Committee Coordinating Ministry for Economic Affairs Indonesia, and also Rector of Institut Pertanian Stiper in Stiper, Yogyakarta.
The third is Professor Dr. Muhammad Kamil, FIE, a professor in Petroleum Studies, Aligarh Muslim University, Aligarh, India.
The last but not least, Dr. Reza Dafarnejad, an Associate Professor of Chemical Engineering Department, Arak University, Iran. This session will be moderated by Professor Dr. Hadianto, Sarjana Teknik, Master of Science.
Professor Dr. Hadianto, Sarjana Teknik, Master of Science, was born at Pemalang, 28 October 1975. He gets his Master of Science and doctoral degree from Wageningen University. Prof. Hadianto is currently working as a lecturer at Chemical Engineering Department, Universitas Diponegoro, and also as the Vice Dean for Academic and Students Affairs on School of Postgraduate Studies, Universitas Diponegoro.
Professor Hadianto has a research expert on food processing, bioprocessing, microalgae, environment, and bioenergy. Moreover, Prof. Hadianto has a tremendous research experience as he was also a researcher on NISO Food Research, TU Delft, KU Leuven, the editor-in-chief of International Journal of Renewable Energy Development, and currently working as the supervisor at Biomass and Renewable Energy Group, Chemical Engineering Department, Universitas Diponegoro, Indonesia.
Please welcome our remarkable moderator, Professor Dr. Hadianto, Sarjana Teknik, Master of Science. To Professor Hadianto, the time is yours.
Thank you very much for Master of Ceremony. Good early afternoon, ladies and gentlemen. Welcome back to the conference programs. I am Hadianto, is already introduced by the Master Ceremony from Chemical Engineering Department, Diponegoro University. It is my pleasure to be the moderator for this second sessions of International Conference on Chemical and Material Engineering 2020. I hope you still enjoy this conference and will be participating also until tomorrow. First of all, ladies and gentlemen, I introduce you to for all our speaker. Yeah, the first speaker is Dr. David Pho. Dr. Pho is currently Director Center of Excellence for Green Energy and Environmental Nanomaterials, Nguyen Tat Tan University, Vietnam. He was graduated from School of Chemical Engineering, the University of New South Wales, Sydney, Australia. He has gained so many awards, research grants, and patents, and also actively involved in editorials membership of several journals, including associate editors of Applied Nanoscience Journal, this published by Springer's, Journal of Green Processing and Synthesis by the Greuter, and etc. I think we should be honored to have you, Dr. Pho, in this conference. Good afternoon. The second speaker will be Dr. Harsawardana. Dr. Harsawardana graduated from Bonn University, Germany, in the area of Masonry and Biosystem Engineering, and currently working as associate professor as well as director of the Institute Pertanian Stiper, Yogyakarta. He also gained several research and innovations grants, both from national and international level. Selamat sore, Pak Harsa.
Selamat sore, Prof. Hardianto. Ya, selamat sore. Ya, good afternoon, everybody. Ya, nice to have you here.
Okay, thank you. Our third speaker will be Dr. Reza Dafarnejad. Good afternoon, Dr. Reza. Dr. Dafarnejad focused himself on the supercritical technology, including thermodynamics and also biotechnology. He was awarded PhD degree in 2010. Dr. Dafarnejad so far has more than 80 publications and research activities. Furthermore, he worked also as process engineer in Stazan Petrochemical Corporations, as a researcher assistant in University Sains Malaysia, and as an invited lecturer in several universities. He has been joined the Chemical Engineering Department of Arak University as an assistant professor since 2010. The last but not least, we also have Professor Muhammad Kamil. Good afternoon, Prof. Kamil. Prof. Kamil is currently full professor from Department of Petroleum Studies, Zakir Hussain College of Engineering and Technology, Aligarh Muslim University, India. The current research is mainly focused on heat transfer, fluid circulation, and boiling experience in a vertical tube thermosiphonary boiler. Prof. Kamil is also already publishing more than 100 articles, including journal and proceedings. Thank you, Prof. Kamil, for being present in this conference. Ladies and gentlemen, to run smoothly in the programs, please mute all your speaker. The presentation of each speaker will be around 20 minutes, 25 minutes, and we will let the speaker deliver. We will let all the speakers deliver their presentation, and after that, the question and answer will we can start. However, if you have any questions before all the speaker finish the presentations, please just write down all the question in the Zoom chat box, and the presenter will read, of course, and respond directly, and will get to you orally after the presentation finish. Ladies and gentlemen, before further ado, I would like to invite the first speaker, Dr. Pho, to deliver his presentations. Ladies and gentlemen, please welcome Dr. Pho.
Hi, I'm not sure how to load the screen on. Sorry.
We can help you to share the screen if you like.
I can open the slide now. Sorry.
Oh, okay.
Okay, can you see my slide yet?
Yes. Yeah, perfectly. Thank you.
Okay. Okay. or maybe you see the full slide, or only the? Can you see the full slide or not?
Yes.
Haven't. You need to, I
Haven't.
think it should be full screen through the bottom below.
Okay.
Slideshow. Yeah.
Have you solved it? Okay.
Yeah.
Good afternoon, everyone. Thank for the kind introduction to the chairman. I'm Việt Vô from Nguyễn Thành University, Hồ Chí Minh City, Vietnam. It's a great honor for me for having a chance here today to give a talk about advanced catalytic reforming processes of biomass derived feedstock for hydrogen generation. So in this talk, I will, this outline, I will give a brief introduction about hydrogen energy, followed by sorry, can you hear me clearly or not?
Yes.
Yes.
Yeah. Followed by the methane reforming, in which I will show talking about the catalytic preparation, corrosion, reaction, and kinetics, and then move on to some of the advanced reforming reaction. For example, bioreforming, oxidative reforming of biomass derived feedstocks. So it's well known that fossil fuel is the main energy which contribute to about 80% of world energy consumption. However, combustion of fossil fuel leads to a large amount of greenhouse gas emission, causing global warming and climate change. So the fossil fuel will be depleted in the next 50 years, and then the high price of fossil fuel leads to requirement of an alternative and clean energy to replace fossil fuel. So among the renewable energy, we think about syngas. So what is syngas? It's a mixture of CO and hydrogen. If we can use it at the intermediate feedstock for a wide range of petrochemical processing process. For example, we can use it in the feature synthesis to produce synthetic diesel, or we can produce gasoline to replace fossil fuel, or we can use in the other type reaction for producing alcohol, ammonia, aldehyde, or we can use it for methanol production. We can use and then we can get other type of essential petrochemical. And we can see here in the future, hydrogen will be the main energy. If we separate out hydrogen out from the syngas, we can use in the hydrogen car in fuel cell due to its high energy capacity. Hydrogen research is a hot topic at the moment. If we go to Scopus with the keyword hydrogen, we can easily find more than 1,000 papers within a week. And then you can see here there's a strong link between hydrogen area with other parts like how to produce hydrogen using combustion, gasification, reforming. Or we can see it in the other part like photocatalysis, electrochemical, and then catalysis also to produce hydrogen. Also the fundamental study like density functional theory to study about the bonding, apply our kinetics for the hydrogen reduction techniques, and also hydrogen storage. So this shows that hydrogen is a hot area for research at the moment. So how to produce hydrogen? They can use a wide range of techniques. For example, here they use thermochemical, in which they have decomposition, pyrolysis, gasification, reforming, or we can use a biological process to produce biohydrogen, which is more green, or a photochemical. We can use a water splitting using the photocatalysis to generate hydrogen. However, this approach is not commercialized yet. Or electrochemical, photoelectrochemical approach. However, in the talk, I only focus on a small part, like reforming processes only. So how they produce hydrogen using reforming processes in industry? At the moment, they have three main approach. They use partial oxidation. It's a reaction between hydrocarbon and oxygen to partially form CO and hydrogen. Or we can use steam reforming. It's an endothermic reaction. You have hydrocarbon react with water to form CO hydrogen. And then they can combine the partial oxidation and steam reforming into one process they call autothermal reforming. So why they do that? They want to utilize the heat from the partial oxidation to supply to the steam reforming process to save the energy. However, the process has some weaknesses. For example, the partial oxidation, they have the problem with the consumption of oxygen hotspot, hard to control. For the steam reforming, they have problem with water consumption and release a large amount of CO2. Therefore, we're thinking about another approach we call methane reforming. So, what's the benefit of it? We have the reaction between two greenhouse gas, methane and CO2, and convert it to syngas with the ideal hydrogen CO ratio. Here is 2:1. We refer for downstream fixed job synthesis. So we'll have a look at the list of the reaction which occur during the methane reforming. We have it like a methane reforming, methane decompose, reverse Bodo reaction, reverse water gas shift, carbon gasification reaction. However, in here, apart from the methane reforming, the methane decompose reaction is a challenging reaction. It's an unreversible reaction which cause a lot of carbon deposition, leading to catalytic deactivation. So now I give an example, a case study, how to produce conducted methane reforming using yttrium promoted cobalt on meso alumina calyx for the methane reforming. Here we use meso alumina to utilize the confinement effect, the high surface area of support, and then use cobalt to have a high stability and low carbon deposition. We top up with yttrium to reduce the carbon deposition and enhance metal dispersion. So for the methane reforming, we investigate the effect of yttrium loading to see what is the optimum of promoter loading. With the varying parameter from 1 to 5% of yttrium loading. So firstly, we look at how the material synthesis. For the alumina, we use a hydrothermal approach using P123 as a template and add in the aluminum isoruboxide, followed by hydrothermal treatment, then go to followed by drying and calcination. Or we can use the aluminum nitrate at the metal precursor instead of aluminum isoruboxide. For the lowering the calyx, we can use incipient impregnation method to lowering the cobalt using the for 10%, and also for the yttrium with the varying lowering from 1 to 5% of weight percent. So now I would like to show you how the reaction look like, the setup. We have a standard fixed bed reactor. We have a gas station, the gas controller, and the fixed bed, followed by the cold trap and dry bed to capture water, to separate water from the product. And then we analyze the composition in the GC. So firstly, we look at the property of the calyx. They have a high surface area ranging from 150 to 200 meters square, and the crystallized size of cobalt 304 quite high to 10%. From 9 to 12 nanometer, showing the fine dispersion of the metal on calyx surface. For the XRD analysis, you can see the presence of cobalt 304 and cobalt aluminate. The cobalt aluminate showing the strong interaction between cobalt 304 and the support. Now look at one of the important of the calyx is the reducibility. By performing hydrogen temperature program reduction, you can see the calyx is reduced completely from cobalt 304 to cobalt 0 under hydrogen activation. With the addition of yttrium, the reaction temperature reduced, showing that the yttrium has enhanced the reducibility of calyx. Therefore, the degree of reaction will be higher, higher percent of cobalt 0 metal. We look at the sum of the performance of calyx in the methane reforming. We vary temperature from 900, about 100 to 1053 Kelvin. You see the methane and CO2 conversion increase significantly from 40 to 80%, and the same behavior for the yield of hydrogen and CO, showing that This one due to the endothermic nature of the methane reforming. Now we look at how is the role of the feedstock composition. We investigate the effect of CO2 partial pressure and also the methane partial pressure to investigate the kinetics. We see if we fix the methane partial pressure at 20 kilopascal and vary CO2 partial pressure from 10 to 40 kilopascal, we'll see methane CO2 conversion drop due to CO2 is an excessive reactant, while methane conversion increase because methane will compose to carbon and it will be gasified by CO2 to form CO and hydrogen. And the result, we had an increasing yield of CO and hydrogen with the increasing CO2 partial pressure. For the effect of methane partial pressure, we see the opposite trend. With the CO2 conversion increase, while the methane conversion drop due to carbon deposition at high methane composition, leading to the drop in CO and hydrogen yield. For the effect of promoter, we can see the catalytic is stable, and we find out 5% of yttrium loading is the optimum loading due to the reduction property of yttrium. And then the basic property of yttrium, it can enhance CO2 absorption organic surface to bring down the higher conversion of the reactant. And hydrogen CO ratio is less than 1, which it can be referred in the downstream feature job synthesis to reduce long-chain hydrocarbon. We also compare the catalytic performance with other type of promoter, the rare earth promoter, and we find out yttrium still the best. This could be due to the basic property of yttrium. However, we cannot confirm it yet, but quantitatively, due to we need to have the CO2 measurement, CO2 TPD measurement, which is not available in our lab at the moment. So we think, hopefully in the future, we can have some collaboration for helping solving this issue. Now look at the kinetic. We use different kinetic model derived used from literature basing on different type of mechanism. Say whether CO2 and methane will absorb molecularly or dissociatively on the catalytic surface on one active site or two different active sites. And we find out that the model number 5 here, in which dissociative absorption of methane and CO2 on single active site is the best model, which capture all the catalytic performance, satisfy both the statistical and thermodynamic criteria, which have high R-square value and small root mean square deviation, and it satisfy the Baudin Venice. So you can see the good fit, the closeness between the formation rate and also the predicted rate for the model in the parity plot. So in this mechanism, we can confirm the methane reforming reaction follow the mechanism in which the methane will absorb dissociatively to have CH species. It will further react with oxygen to form CO and hydrogen, in which oxygen species is obtained from CO2 dissociatively absorption. So how is the yield catalyst really an important characteristic to see whether catalyst can be stable, can be changed during reaction or not. You can see a large amount of carbon forming the reactive carbon. However, the amount of the reactive carbon is dropped at 3% yttrium loading. Showing that with an in yttrium, it can suppress carbon deposition. But how much is carbon deposition? You can see it has been reduced significantly by doing the TVO measurement, and 3% yttrium it had the lowest value. So here, why is the carbon can reduce? It due to an intermediate phase formed during the action, in which yttrium will react with CO2 to form lithium deoxycarbonate. This intermediate phase will react with CH species to form CO and hydrogen. Therefore, it can prevent the catalytic surface from carbon deposition and maintain the catalytic stability. We look at the TM, you see the dispersion of the metal on the surface of support. However, there's some metal upon rate, which we very hard to control because the catalyst will calcine at very high temperature. This is the witness of the catalytic reaction in the methane in the chemical reaction. For the spent calyx, we have seen the presence of carbon nanofilament on the surface of support, but the calyx is not deactivated because the carbon nanofilament will not encapsulate the calyx, the active site, like the reference carbon. That's the reason why the calyx is stable, although there are a lot of carbon nanofilament. You can see here from XPS analysis, you can see the reduction the oxygen vacancy is very high with in lithium. Therefore, the oxygen vacancy can help to remove the surface carbon from calyx surface. Now I will move on to other type of reforming process. The advanced one, for example, the methane by reforming, and then also methane we see is also natural gas. So we think about whether we can use other type of biomass derived feedstock or not by performing methane reforming and also oxidative reforming. So let's move on to the first one, the methane reforming. So it's reaction between methane and water and CO2. We have two reducing oxidizing agent to form CO hydrogen with ideal hydrogen CO ratio to 2:1. So we add in one more reactant in water. Here you can see we're using methane by reforming on the 3% boron promoted 10% nickel sp15 calyx, and there's no in actually there's no peak for the carbon deposition, no reference carbon, and also SAM also showed there's the absent in the carbon deposition. So why is like that? This is because they have two reasons. Firstly, we have two reducing agent, oxidizing agent, water and CO2. So if carbon form on a surface calyx, it will be gasified to CO2, or with the add-in of boron will occupy the first surface layer of nickel, and it is the site for carbon diffusing and growing like carbon island. But this site was preoccupied by boron promoter. Therefore, the amount of carbon deposition is reduced. Now we look at another type of reforming using biomass derived feedstock like ethanol. We can obtain from biomass really widely available in Southeast Asia, like in Indonesia, Malaysia, and Vietnam. So there are large amount of biomass. We can generate ethanol, and from there we can perform the reforming to react with CO2 to form CO hydrogen. So the ethanol reforming, the reaction is quite complex compared to methane reforming. Since apart from the methane ethanol reforming, the hydrogenation, they also the decomposition of ethanol to methane, and the methane will further react with CO2 to form syngas. So now I show some of the result, and from there we can see hydrogen CO ratio is higher than 1 in the ethanol reforming reaction due to the ethanol dehydrogenation reaction. So and we can find out that the ethanol reforming occur in two main steps. The ethanol will decompose to methane, and then methane will react with CO2 to form CO and hydrogen. But the weakness of ethanol reforming, we can find out a lot of carbon deposition. So why? Because ethanol we have two carbon. So it's higher than methane. Therefore, they have more chance of carbon deposition in the ethanol reforming. So we think about how to reduce it. We come up with another way of reaction. The solution is we're using the reforming. We introduce oxygen in. So if carbon deform, it will be oxidized by oxygen. So we are the first one suggest this approach for reduced carbon deposition. We can see here the conversion reached a very high value, nearly 100%, and then around 70% for the hydrogen yield. Interestingly, carbon deposition has been reduced significantly from 51% to 28% with the add-in of oxygen. Another way, another type of feedstock we can use for the ethanol reforming. For example, I can use ethylene glycol, which is one of the main components in the bio oil. So if you do biomass, the fast pyrolysis of biomass, we have bio oil in which we have a main component ethylene glycol. So I use ethylene glycol to convert it to hydrogen CO, and this successfully. So we think maybe in the future it's a new area. We use directly the bio oil and the feedstock react with CO2. We can generate CO and hydrogen directly. Okay, in conclusion, we think like we can use lithium add-in can enhance the stability and PP catalyst and PP centrium in the optimum loading. So this is due to the mobile oxygen storage capacity of the lithium promoter. It enhances the gasification of carbon and prevent catalytic deactivation. With different type of reaction process, we can manipulate the hydrogen CO ratio to obtain a suitable hydrogen CO ratio for downstream feedstock synthesis to produce a different type of product. So before ending my talk, I would like to introduce a little bit my group. So before and my uni, before I work in University Malaysia, Pahang, and this is my previous group here. They are doing the job to prepare the talk here. And now I move on to Untitled University. Here is my new my colleague and my team member also during the seminar. So my uni, Untitled Uni, and we have recently have four-star for QS ranking, and the uni is located in Ho Chi Minh City, the south of Vietnam. We have around 9 million people in the city, and the temperature is quite, I think, I mean, the time zone is same with Jakarta. The temperature, I guess, is quite similar, like hot and humid, I guess. There are quite a lot of interesting points for visiting for tourists. For example, we have the Kuchi Tunnel, the army area where we can go down underground and visit the tunnel. Quite interesting point, and also some of the ancient buildings, the historical buildings. And this is my uni, a private uni here. So this is the end of my talk. I think, thank you for your attention. If you have any question, you may ask me now or later. Thank you.
Thank you very much, Dr. Po, for your interesting talk and very inspiring us. Ladies and gentlemen, if you have questions, please keep it a letter, or you can just write down directly to the message box, so Dr. Po can see and respond directly in the chat box, or Dr. Po also can keep orally describing and explaining about the answer after the presentations. Now we continue to the second presenter, that will be Dr. Harsa. Dr. Harsa?
Yes, I have been here. Yes, hello. Yeah, I've been here.
The time is yours.
Yeah. How about the file? The file is from here, or the file is from you? I have already sent a file, recorded PowerPoint, but if you have any difficulties in presenting the file, then I think I can run from here.
I think it will be better if you can directly remote, or you can directly control the presentation from your side.
Okay, then I've already recorded, and I will run my recorded PowerPoint. So let me first let me first share screen. Yeah? Okay.
Yes.
Just a minute. Yeah. Okay.
Good afternoon, ladies and gentlemen. Today I want to present sustainable palm oil industry for sustainable development goals. We know that oil palm trees start to bear fruits after 3 years old, and their most economic life is between 5 to 15 years, although palm trees continue to bear fruits until 25 to 30 years old. but due to the difficulties of harvesting the fruits, normally after 15 to 18 years, the people replant it. The common oil palm trees yield about 5 to 5 tons of crude palm oil per hectare per year and about 1 ton of palm kernel. You can see here that the palm oil industry contributes itself 35% of the need of vegetable oil in the world. And due to the so many derivative products produced or derived by palm oil, these commodities play a significant role in some countries like Indonesia, Malaysia, and others countries that has a plantation of palm oil. Here we can see quite clearly some product or many products that derive from oil palm. You can get here the main product is crude palm oil and palm kernel oil. From both we can see that here some of the products are derived or produced from both of the main product. The Sustainable Development Goals in some country like Indonesia is supported by Indonesian sustainable palm oil. It means that without sustainable of palm oil as a major contributor to the Indonesian economic, SDG, it cannot be achieved. So you can see here that the session of ISPRO criteria contributes at least 12 of 70 Sustainable Development Goals. Comply to regulation and law. The second is best management practices. The third is environments, natural resources and biodiversity management. The fourth is responsibility toward worker. The fifth is social responsibility and empowering of society welfare. Six is transparency, and seven is sustainable business. The action that taken by some industry like palm oil industry, such as emission reduction, has a significant impact on the sustainability of development goal. This is why that the industry has to comply to ISPO to make sure that they can contribute or they can be sustained in the long run. The energy is one of the aspect that must be managed well. Here together we see the biomass balance and utilization of palm oil biomass. The palm oil tree produces only 10% oil, but the rest is 90% biomass. This fact makes us thinking that the development of the technology, such as the energy technology, is essential to keep the industry, such as palm oil, to be sustained in the future. Here we see some of the waste that are produced by palm oil tree. Front strand. In the meantime, the people only put this waste on the surface of the field And from the palm oil tree, we have a fresh fruit punch that will produce CPO, crude palm oil, and other waste product. The waste product that we can get from here is solid waste and liquid waste. The solid waste that you can have here is empty fruit bunches, fiber, kernel cell, and the solid liquid waste that you can get is palm oil mill effluent that normally people call it as a pomade. From all the waste, we can produce energy from there. Here we see the flow process of the palm oil. The process starts from the fresh fruit punch, FFB, coming to the sterilization station, and after the sterilization goes to dressing, digestion, pressing. The whole process is powered by steam turbine. This is a must or mandatory that for getting the profit, the process cannot be powered by fossil fuel. The boiler get the fuel from the process itself. The fiber goes to the boiler, and the boiler generates high pressure steam that will run the steam turbine, and the steam turbine will run the generator to generate electricity that power the whole system in the palm oil mill. The biomass conversion, it is considered to be a technology that will develop in the future because of one clear reason that 90% of the palm oil tree produce 90% biomass. The biomass conversion is driven by the first zero waste policy and also of the price of solar for industries higher and non-renewable. It is clear that makes sense that the palm oil mill use solid waste as a fuel for running the power station. The palm oil mill effluent as a liquid waste produced by the mill is a potential biomass to be processed for biogas. Of course, there is added value on downstream product such of crude palm oil, CPO, palm kernel, and palm kernel oil. By biomass conversion, we can also generate electricity by some conversion technology. And also now is becoming important for the industry that reducing emission of greenhouse gas is a mandatory for the industry. The biomass conversion technology exists. Traditionally, it's direct combustion, means that by burning directly the solid waste in boiler. There are some technology also that now is becoming popular in the palm oil industry, like biochemical conversion, or now is becoming the first technology that used by most of the industry is thermochemical conversion. That use the process of anaerobic digestion, and in the end the biogas will be cut. The biogas will be fed up into the gas engine that produce electricity for other uses. There are some other technology that also available, but normally the industry only use three kind of biomass conversion technology. The first is, of course, direct combustion. That this is the process that used for many years since this industry started. And the second is biochemical conversion, and I think the second technology that now is becoming popular in industry is thermochemical conversion. This is, we can see that boiler house, that this construction is normally we can find in that industry that uses steam turbine and boiler for generating electricity to meet the demand of the power of the mill. One of the programs to get the ISPO certificate, Indonesian Sustainable Palm Oil certificate, is emission reduction. The source of emission reduction, you can see here, there are some: methane from pome, fertilizer, fossil fuel, pesticide, chemical substances, and state electricity. Pesticide and chemical substances are considered less, much less than others. Methane and fertilizer is considered as the two big contributor of the emissions. So the methane from pome is used to generate electricity, and the fertilizer is reduced by applying the precision farming that only use the fertilizer that is really required by the plant. So we can see here that the technology of gasifier. This technology is used by some company in Indonesia to produce electricity in plantation that cannot get the electricity from the mill because of the distance. Here, this gasifier uses kernel cell as a fuel, and by gasifier, the system can give the synthetic gas and use as a fuel for this diesel engine. This diesel engine also use diesel fuel. So almost 60 up to 40% of the fuel is from the synthetic gas. But this technology is still on trial. That it is not widely used, but some of the companies try to use this system. So you can see here the whole picture of the system that uses reactor, and you can see here transparator and S collector, tar filter, 2C this gas cooler, and here below on the right you can see how the system has been connected with the diesel engine. Small diesel engine is about 11 horsepower, and then this engine will rotate this alternator. The alternator will produce electricity for the domestic purposes in the plantation. This is also one of our setup, our research on bio-oil pyrolysis. This is one also of the system. You can see here the left one, the whole system is can be seen here. And the system uses the electric periodic discharge. Many companies in Indonesia make a methane capture program as carbon emission management. They use the biogas just only for flaring, but there are also some companies that use a system that can generate electricity for own consumption, like the electricity for kernel crushing plant or electricity for domestic use. Some effort also was carried by some company to sell the electricity to state electricity enterprise. The main aim, this program aims to reduce greenhouse gas to support Indonesian sustainable palm oil certificate. And here we can see how the system of biogas using the lagoon system. And they put plastic over the anaerobic ponds, and from there they put biofilter, they put intercooler before this biogas going into the biogas engine. Some of the company in Indonesia also use this system for electricity generation. Here you can see that an example of biogas cover lagoon. The biogas system generate 1 megawatt, and this electricity is used for running kernel crushing plant and also for domestic usage. Here is we can see one example of biogas system. It is closed and generating biogas by putting the material in a reactor. The difference between lagoon and closed is lies on the reactor, and the lagoon lies on the anaerobic pond. Here we can see the whole picture in one company in Indonesia that already use closed system for generating biogas. Here we can see an effort of one company to use biogas as a fuel for boiling. It looks like that still in the initial state. This is why that we cannot see widely in industry, especially in the palm oil industry. Here we can see the biogas potential. That take one example, that if we have a mill with 60 ton per hour capacity, we can get electricity potentially 8 million kilowatt hour per year, and we have an emission reduction potential up to 60,900 CO2 per year. So I can conclude that to achieve the sustainable development goals in Indonesia only can be achieved through Indonesian palm oil, Indonesian sustainable palm oil. Without that, it's quite difficult to get the target. Thank you very much, and waiting for question and answer.
Thank you very much, Dr. Hardi, for your
Ya, terima kasih Prof. Hadianto ya tadi paparan kami. Ya.
Oke.
Kami menunggu diskusi nanti bila ada yang tertarik.
Yes, thank you. Dr. Arsa is a great practitioner for palm oil industry, and he show us how possible energy product from the palm oil processing, including biogas, bioelectricity, yeah, and then biomass. And then we have to move to the third presenter. It should be Dr. Dessy. Dr. Dafar Nejat. Can committee confirms whether Dr. Reza already joined or not yet?
Yeah, can we proceed to Prof. Muhammad Kamil first because he sent us the video of his presentation?
Okay, thank you. Okay, we continue to the fourth presenter, is Professor Muhammad Kamil, but he's not able to join us via Zoom's meeting, so he sent us the video presentations, but it is okay. So you still can have questions sent to the committee, and then we will directly forward to Professor Kamil. Committee, please display the video.
Assalamu alaikum to everyone. I am Muhammad Kamil, working as professor in the Department of Petroleum Studies, Zakir Hussain College of Engineering and Technology, Aligarh Muslim University, Aligarh, India. Now, at the outset, I would like to thank Professor Dessy Ariyanti, Diponegoro University, Indonesia, for his invitation for this conference. Now, before I proceed to my talk, let me give some brief introduction about the Aligarh Muslim University, Aligarh. Now, Sir Syed Ahmad Khan, he has founded the Mohammedan Anglo-Oriental College in 1875. Later on, the MAO College, which was established by him, was transformed into a central university, that is Aligarh Muslim University, Aligarh, in 1920. AMU is ranked by NAC, that is a National Accreditation Agency, by securing grade A. It is one of the second best in the country. The university has 12 faculties, a number of colleges and centers. There are around 30,000 students, mostly. The character of the university is basically the residential one, and around 2,000 faculty members are working in this university. Now, the Title of my talk is Studies on the Boiling Binary Liquid Mixtures in a Natural Circulation Vertical Thermosiphon Boiler. So the outline of my presentation basically involves the basic introduction about my talk, the flow inside the vertical tubes, what is the flow pattern and heat transfer regimes, experimental empirical modeling of saturated boiling region, results and discussion, and conclusions and the future recommendation for research work. The vertical thermosiphon reboilers are essentially a one-one heat exchanger fitted in a U-shaped circulation system. It is widely used in number of process industries and also in the cooling of electronic equipment and nuclear reactor fuel element during shut-off periods. The boiling heat transfer, on the other hand, plays a very significant role in the design of vaporizers, evaporators, reboilers, and similar equipment which are used in the process industries. This may serve as a potential means of transferring solar energy, requiring efficient heat transfer with little or no force flow, providing a solution to the problem of transportation and storage of solar energy available in abundance. Under the present energy crisis and need for better methods of its conservation and economic utilization, thermosiphon reboilers may receive increasing attention as energy efficient equipment in many other applications. These units are characterized by high heat transfer rate and low fouling tendencies. The liquids have short residence time, minimizes the risk of thermal degradation of fluids. It is highly reliable. It has far lower operating costs than other type of reboilers. It is easy to set up and has compact dimensions. This can be used in a wide range of operating pressures and temperatures. Therefore, they are used for about 70% of all evaporation duties in process industry. Generally, the boiling of liquid takes place inside the tubes. The heating medium, which is generally a process steam, usually flows in the shell side. These are some of the typical configurations of thermosiphon reboilers. Figure 8 deals with the vertical thermosiphon reboiler, which is connected to the column by a liquid feed line. Usually, a valve for controlling the liquid flow rate is installed in the inlet pipe. The liquid enters the heat exchanger at the bottom and is heated and partially evaporated inside the pipes. A vapor-liquid mixture leaves the reboiler through the exit line. The liquid circulation is driven by the difference in static pressure between the liquid in the inlet line and the partially evaporated fluid in the reboiler. So basically, there is a density difference for the flow. No pumping is required for circulation. Therefore, the design of thermosiphon reboilers has to take special care for low pressure drop. The once-through naturally forced vertical thermosiphon reboiler is installed in distillation column. D is the forced type, where basically in the forced circulation there is a pump which is installed in the inlet line. Another configuration is same. The C is the vertical thermosiphon reboiler with fixed liquid head. The special design for the bottom of the column as shown in figure C ensures a fixed liquid level feed to the reboiler even if the flow rate from the column varies. A reboiler where the liquid from the column is heated by once is called a once-through vertical thermosiphon reboiler as shown in figure D. A short residence time of the liquid in the reboiler can be achieved with this design of the reboiler. However, just a small fraction of the liquid is evaporated. A very sophisticated design as shown in figure E has the advantage of a forced circulation reboiler without the disadvantage of a pump. When a low boiling substance has to be separated from a high boiling mixture, the configuration C, that is the once through naturally for circulation thermosiphon reboiler is the best. Now, this is the diagram showing the flow patterns, boiling regimes, and temperature profiles in a vertical thermosiphon reboiler. So, this is the liquid temperature profile for mixtures. It is for the pure fluid. Wall temperature profile for the pure liquid, and this is for the mixtures. And this is regarding the extrapolation to show the saturation temperature of the liquid in the case of pure fluids. Now, generally, a subcooled liquid entering the tube receives the heat, sensible heat, and its temperature rises as it moves upward. So the temperature has been shown here. Both the liquid temperature and wall temperature almost linearly vary and are parallel to each other. As soon as the wall temperature attains a particular value, that is the minimum degree of superheat is attained, the bubbles begin to grow at the surface. The wall temperature deviates from linear behavior while liquid temperature continues to increase till it attains saturation value. The bubbles grow in large numbers and populate whole cross section, that is the bubbly flow, and finally coalesces into the slug flow. The chain of slugs join together, forming a core of vapor and liquid film at the wall, that is the annular flow. This annular flow film is gradually depleted and thinned out, resulting in the vapor carrying the fine droplets, that is the mist flow. The saturation temperature of single component liquids basically decreases along the tube length due to the reduction in hydrostatic head. The corresponding wall temperature also decreases, but at a faster rate. However, in the case of binary liquid mixtures, the liquid temperature beyond the saturation value, that is the bubble point temperature, increases as a result of the dominant effect of preferential evaporation of more volatile component and the rise in concentration of higher boiling component in the remaining liquid. The wall temperature in the saturated boiling regime is much larger than that for the pure liquid due to the detrimental effect of mass diffusion on the boiling process. The flow pattern distribution resulting from the boiling of liquid and thermally induced flow in a vertical tube depend upon several parameters such as heat flux, inlet liquid temperature, liquid submergence, that is the driving liquid head, and the physical properties of the liquids. The various flow patterns affect the corresponding pressure drop and mode of heat transfer. So you can say there exists a strong interaction between the hydrodynamics and heat transfer, making the process very complex. The nucleate boiling heat transfer in binary or multi-component liquid mixtures is strongly influenced by the composition of the mixture, as observed by a number of researchers in their flow boiling studies. The heat transfer coefficients were found to be lower than those from the pure component liquids. Now you can see the regimes of heat transfer. It is the single phase or convective heat transfer to the liquid. Then it is the subcooled boiling, and after this it is the saturated nuclear boiling. So this is basically the area where we are focused, and I am going to develop a very unified and generalized correlation for the prediction of boiling heat transfer coefficient. And finally it becomes the liquid efficient region and convective heat transfer to liquid film. Now, with natural circulation boiling of liquid mixtures as encountered in thermosiphon boiler, therefore you can say composition becomes an additional controlling parameter. So the basic objectives of this present investigation is to study the effect of concentration or composition on the heat transfer coefficient, to develop a generalized correlation using mixture boiling correction factor for the prediction of boiling heat transfer coefficient, and to compare existing nucleate boiling correlations for predicting heat transfer coefficient both for methanol water and water ethylene glycol systems. The experimental apparatus, basically it is the diagram showing the test section. It is a vertical tube, stainless steel tube, which was electrically heated with the help of low voltage high current transformer. It is the vapor liquid separator, it is the condenser, primary and secondary both. It is the downflow pipe and it is joined by the horizontal pipe. And this is the rotameters in order to provide the cooling in the case of condenser. This is the bubbler to see the vapor bubbles. If they are absent, it means the liquid has been completely degasified. So the experimental rig was basically in the form of a U-shaped circulation system made of two long vertical stainless steel tubes whose lower ends are connected by a small horizontal tube, while a vapor liquid separator, this one, and condenser vessel were fitted to the upper ends. The test section is basically, it was 25.56 millimeter ID, 28.55 millimeter OD, and out of the total length of 2100 mm, a section of 1900 mm was tapped between two thick copper clamps, which were designed to provide electrical connection to the tube with almost negligible contact resistance. In order to monitor the heat transfer surface temperatures, 21 copper constant thermocouples were spot welded on the outer surface of the tube at intervals of 50 mm up to a length of 200 mm from the bottom end and 100 mm intervals over the remaining length of the tube. The temperature between the two walls of the sampling device was maintained at 0 degrees centigrade by placing melting ice in it. This arrangement proved quite effective for instant and complete cooling of the sample and thus avoiding vapor loss. So after cooling the sample, the inner tube was taken out and kept in the refrigerator. The refractive index of the samples were determined and the composition read from the refractive index composition chart of the system under study. So this procedure was followed for various compositions of each binary liquid mixtures of methanol water and water ethylene glycol system. The composition of a binary mixture was judicially selected based on the behavior of y minus x versus x plot of the system. The maximum liquid head used in the present study corresponded to the liquid level equal to the top end of the reboiler tube. This condition has been termed as 100% submergence. And other submergence levels like 75%, 50%, and 30% were maintained. So the experimental data were generated at 4 different levels of submergence and various heat fluxes. While changing over from one system to the other, the circulation system was freed completely from the previous mixture. The entire setup was thoroughly legged to make the heat loss negligible. Heat balance calculations were carried out, which were less than 2.5%. Other details of the reboiler and cooling system and procedure is given elsewhere by Kamil and Kamil et al. This is the photograph of the thermosiphon reboiler in the research lab of the department. Now the range of various parameters like heat flux, submergence, and concentration of more volatile component. Here, for the case of methanol water system, the heat flux was varied from 5,700 to 29,000 watt per meter square. For water ethylene glycol, it was 4,100 to 33,000 watt per meter square. Submergence level were varied from 30 to 100%. Composition for the case of methanol water, it varied from 5 to 58. For water ethylene glycol, it varied from 5 to 57. The data processing was carried out by considering the thermal equilibrium model as suggested by Saha and Zubair, and that was used by a number of investigators, including the author's own study. And based on that, the heat balance was carried out around the condenser, and we have calculated here the liquid condensed from the condenser. These are the boiling length and non-boiling length. This is the liquid circulation through the reboiler tube, and this was calculated by equation 5. The liquid temperature profiles in the non-boiling zone as well as in the boiling region, they were calculated by equation 6 and 7. The vapor fraction was calculated as by equation 8. Heat transfer coefficient in the boiling as well as non-boiling section were calculated by this expression as is equal to Q delta T, where the temperature drop delta TW between the thermocouple bead and the inside surface was estimated using the equation of conductive heat transfer with internal ionization for a cylindrical valve. The length mean values of heat transfer coefficient in the boiling region was calculated by equation 10. Now, the estimation of physical properties for pure liquids as well as binary liquid mixtures was carried out firstly by the equation of polynomial, and the single component properties were estimated at the desired temperature. So you see that the physical properties of pure fluids are available in the literature as a function of temperature, but with a limited range. For the calculations developed in the study, property values beyond the published ranges were required, which necessitated extrapolation. So we had used the fourth power degree polynomial from the literature. The properties were calculated by the equation of this polynomial. P is equal to a plus bt plus ct square plus dtp plus et raised to power 4, where P is the property, T is the temperature, A, B, C, D are constants of the equation. So the constant of polynomial obtained for various physical properties of water, methanol and ethanol glycol were obtained. After that, we had used the various correlations from the literature in order to compute the density, specific heat, viscosity, surface tension of binary liquid mixtures. Now, come to the nucleate boiling correlations of binary liquid mixtures. They are first popular one is the pool boiling correlation by Schlunder. The theoretically derived correlation includes the effect of heat flux on the mass transfer process for binary liquid mixture in terms of this equation, where Hi is the ideal heat transfer coefficient and V naught is the empirical scaling factor representing the portion of the heat leaving the surface in the form of latent heat, and has been set to 1 by Schlunder. In addition, he assumed that the liquid phase mass transfer coefficient beta L has a constant value of 0.002 meter per second. Then we have the Thom and Shakir correlation. Basically, it is given in terms of mixture boiling range delta T dt. And this is the Bennett and Chen correlation, which is based on basically the slope of the bubble point curve dt by dx, and we can calculate the heat transfer coefficient. The Callas and Rice correlation, which is based on the concentration gradient y minus x. So this is basically the correction factor, and Hi is the ideal heat transfer coefficient. Paulin has given this correlation in order to calculate the heat transfer coefficient for multi-component mixtures. It is also in terms of boiling range of the mixture. Kamil and Alam correlation, it is given in terms of heat flux, Prandtl number, Brocard-Markey parameter, surface tension correction, and the correction factor in terms of concentration gradient. So these are the boiling correction factors proposed by the researchers in the literature by Bennett and Chen. This is the correction factor. Callas and Rice has given this correction factor. Schlunder, the same one. Thom and Shakir, Palin. and this is Kamil and Alam correlation, which is given as 1 plus yi minus xi whole square divided by y into 1 minus yi. So the modeling of binary liquid mixtures has been carried out. The different modeling equation for heat transfer coefficient have been developed in terms of the different operating parameters, heat flux, thermophysical properties of the liquid mixtures, Locard-Martelly parameter, and surface tension correction. This is the correction factor suggested by Bennett and Chen, Callas and Rice, Home and Shakir correction factor, Palin, as well as Kamil and Alam. So let us study the effect of concentration on the heat transfer coefficient. The figure 3A and 3B basically shows the variation of the heat transfer coefficient along the tube length Z, and we have taken here some heat flux of 16,599, submergence of 100% for methanol water system. Similarly, it is for the water ethylene glycol system. Now here the relative magnitude, position of boiling recipients and nature of variation, they varies with the composition. The change in behavior of the heat transfer coefficient profiles for binary mixtures may be attributed mainly to the physical properties of mixtures being different from those of their constituents, and presumably the effect of mixture composition on the mechanism of boiling process. Further, with the progress of vaporization, the larger quantities of more volatile component go into the vapor phase, reducing its concentration into the liquid phase. The saturation temperature increases and the above effect is intensified. But the higher concentration of vapor phase than that of the coexisting liquid phase in the tube presents the necessary concentration gradient or mass diffusion, that is yi minus xi, which might affect adversely the bubble growth rate. Similar observations in fact were made for water glycol system at different concentrations. Therefore, the variation of heat transfer coefficient with the tube length for binary mixtures are governed by all parameters which are involved for single component liquids and the additional effect of mass diffusion on bubble growth rate in a very complex way. Now we can study the effect of composition on the average heat transfer coefficient. Figures 4A and 4B basically they deal with the variation of heat transfer coefficient that it decreases with increase in the concentration of more volatile component in the mixture up to a certain value, beyond which it increases, showing a minima. The mixture concentration at which the heat transfer coefficient becomes minimum is nearly the same at all heat fluxes and submergences for a system. So it is evident from the figure. However, this value is observed to be around 20% for methanol water and 15% for water ethylene glycol system. The experimentally obtained values of heat transfer coefficient for mixtures are invariably lower than their weighted average at any given concentration. The different values of heat transfer coefficient for mixtures as compared to the weighted average of the constituent components may be attributed to the change in properties on mixing and the effect of mass diffusion on the boiling process. The difference between the two values is minimum at the concentration corresponding to the minimum value of heat transfer coefficient for a given system. During the boiling of liquid mixtures, the concentration of more volatile component in the vapor bubble becomes higher than that in the surrounding liquid. The difference between the vapor and liquid phase compositions provide the necessary concentration gradient for the diffusion of more volatile component from the bubble to the liquid. This process is just opposite of the bubble growth, and hence the rate of bubble growth gets retarded. The microconvective contribution to heat transfer thus gets reduced, resulting in a lower heat transfer coefficient than expected value of the weighted average. The rate of diffusion and hence the retardation of bubble growth is maximum at a concentration at which y minus x is maximum. This is the reason that why the values of heat transfer coefficient are minimum at the concentration which are almost same as those corresponding to the maximum value of y minus x, as may be seen in the figures earlier 5. The correction factor as recommended by KLS and Rice was evaluated, and its variation with concentration of more volatile component is shown in figure 6a and 6b for methanol water as well as for water glycol system. The physical significance of this parameter is that it acts as a correction factor to the apparent temperature difference delta T. This correction factor is valid in any boiling situation as long as vapor-liquid interface exists. Therefore, it is a very powerful tool in pool boiling as well as in fluid boiling for the calculation of the effective temperature difference for binary mixtures. The curves for methanol water and water ethylene glycol exhibit a maxima, and this corresponds to the size and maximum in the value of y minus x of the vapor-liquid equilibrium relationship. So now let me come to the correlations for boiling liquid mixtures in a tube. The design of reboilers for boiling of binary and multi-component liquid mixtures is quite complex due to the non-availability of a generalized correlation for the prediction of nucleate boiling heat transfer coefficient. Therefore, generalized correlation for heat transfer coefficient has been developed in this study, and you see that the main parameter governing the mass diffusion is the concentration difference y minus x, while the nucleate boiling and convective heat transfer are affected by heat flux and mass velocity and flow patterns with varying vapor fraction. So in order to account for the above mentioned contributions, heat flux was taken its dimensionless form as Peckley number for boiling, that is PEB. The other group that accounted for thermophysical properties of liquids were taken to be Prandtl number and the surface tension ratio. The effect of two-phase flow was accounted by the Lockhart-Martinelli parameter to correlate the data. In the present investigation, the correction factor as suggested by KLS and Rice was used to correlate heat transfer coefficient as Nusselt number, and using these dimensionless numbers, a regression analysis of the data basically obtained taking the 152 data points resulted in the following correlation. So this is the correction factor basically that is used. This is the empirical model for this, and the maximum error is plus minus 10%. The range of the dimensionless groups is given in this table, and we have compared also the other mixture boiling correlations. It is that of Bennett and Chen, maximum error is plus minus 25%. KLS and Rice correlation again plus minus 20%. Paulin correlation gives the maximum error plus minus 30%. And this is basically the calculation for the mean absolute deviation, and the percent error is given. So now we can conclude that the heat transfer coefficient H first decreases in the vicinity of tube inlet and then increases slowly up to a point beyond which it increases very fast with the distance along the tube length. Average heat transfer coefficient first decreases with the increasing concentration of more volatile component and then increases, showing a minima, and this minima occurs at y minus x because the rate of diffusion and retardation of bubble growth is maximum at this concentration. Now, the effect of the variation of local heat transfer coefficient with concentration at same heat flux and liquid submergence level is on the relative magnitude, position of boiling and sequence, and nature of variation. The proposed correlation is fairly good. The correction factor F as defined as a powerful correlating impact on binary systems only when the vapor liquid equilibrium exhibits wide variation in the values of y minus x. The correction factor F first increases and decreases with concentration for both the systems, showing a maxima, and this maxima occurs when y minus x is. So with this, I thank everyone for the patience hearing. Thank you very much once again.
Thank you very much, Professor Kamil, for your very inspiring presentations about the correlation of boiling binary liquid mixture in natural circulation vertical thermosiphon reboiler. I'm sure from the participants there will be a lot of questions, and I see that some participants already wrote the question in chat box, in Zoom chat box, and also the so some presentations also already respond, but I think it is better if the presenters, starting from Dr. Pu and following by Dr. Harsha, to respond orally to in these Zoom meetings. So maybe start with Dr. Pu. Are you still with us? Dr. Pu? Dr. David? Or maybe we proceed with Dr. Harsha. Can you respond to the questions that's already written in the chat box?
Yeah, okay, that's the question that there is here. I can read this. For example, it is how much your oil can you produce from 1 kg biomass. That I answer that it is around 20% of biomass weight. I have got the number by using 500 kg capacity of kg bio. This is about 20%. And then question from Prof. Didi, how many percent production of Indonesian CPO as raw material to make biodiesel? I think the exact number is it's not so easy to get because no company want to reveal the data, but I think the rough number is close to less than 10%. Because see that the majority of the crude palm oil for biodiesel is dominated by one company, but I cannot mention here because I think this is the public's the public's webinar, and I think that company don't want to reveal the data, but I think less than 10%. And what is the risk of solid synthesis into bio oil? That this is unfortunate that the experiment is we use the just a minute the cell of coconut palm, but I do believe that the kernel cell of oil palm will give much better result. But I think in Indonesia that is not so. I think maybe I don't know that why people in chemical engineering doesn't want to do some research on oil palm. So I think we cannot get the data, but from my belief that the kernel palm oil will give a higher, because also has the higher thermocaloric value. And I think the bio oil you can get is much more. I think this is my answer. Maybe we can discuss later on when somebody want to argue or to have another number. I think thank you, Prof. Hadianto. Thank you
very much, Dr. Harsha, that already respond to the questions written in the chat box. Now I'm calling the participant who wants to raise your questions. Please just raise the hand through the Zoom facilities, or you can just directly indicate that you want to give questions. I'm inviting from the participants. Okay, maybe from myself, because I also one of the participants. Dr. Harsha, those technology is in the research area, or still in research feasibility studies, or already implemented in Indonesia?
I think we take a look at emission reduction. It's the company or the people want to or tend to try to apply the biogas plant, even though the biogas plant is quite expensive, because if we have 60 tons per hour mill, the price, the cost of building one biogas plant is almost half. Half of the, but there is no, we can say that there is no setback, because this is a mass mandatory for industry, oil palm industry, to put the biogas plant or to do a methane capture program. So this is why also it is that I think there's still room for improvement, I think. But the biogas plant is already used or already built in every mill, because this is a mandatory. But this is for the liquid waste, but for the solid waste, I think research is still lagging. So not many people go to solid waste research. For example, for the empty buns, empty fruit buns, and also the fiber. And I think the room for the research is for the empty buns, because what we are doing now is we just split the empty buns in the field for organic compost, for organic fertilizer. This is why that I think the technology, I think is, we can say that the major technology is biogas. I think even though the provider, the biogas provider, is coming not from Indonesia, mostly from outside. This is why I think this is a challenge for the chemical engineer in Indonesia to set up the startup or something, that maybe they want to do some research on maybe biogas plant, because there are still some drawback at that technology. For example, the up and down of the biogas yield. Sometimes when something happens in a mill, and the potential yield of the biogas is below from the average. This is why some problem are. But because of this biogas plant is mandatory, that there is no reason not to build a biogas plant, then every company will build. Even though that the cost is very expensive, and the performance is sometimes is not as good as we expect. This is my answer. There's still some research that must be done by I think mostly the chemical engineer or everybody who are interested in doing research in biogas or in solid waste, on liquid waste technology.
Thank you. You also mentioned that the operational cost for biogas from palm oil mill effluents will be still high. So I maybe have a questions regarding the cost for if the biogas converted to electricity, and then compared to the electricity produced by national company PLN, how much maybe the cost for those comparisons?
The problem is that it is not the operational cost, but the investment cost. It's mostly half of the investment of building the new factory. So, for example, if we have we build a 60 ton per hour mill or factory, a palm oil factory, the biogas plant will cost almost half. This is quite expensive. But your question is next about. Sorry, can you repeat your question, Prof?
if the biogas from the palm oil converted into bioelectric, converted to electricity.
Okay. We know that the biogas caloric value is not as high the fiber or the cell itself. This is why that if someone or company build a biogas plant, it will meet only the demand of small processing plant like kernel crushing plant, and also some of the domestic demand, but not for the mill itself. The mill must be, the power demand must be met by solid waste, such as fiber and cell. But because of the fiber has a value in the market, and people prefer to sell the cell to the customer and try not to use fiber. But the problem is that some of the variety of the palm oil, it yields high oil, but the fiber is less. That also create problem. Some of the company also, they can create, for example, the oil extraction rate is maybe more than 25% of fruit punch. But it creates another problem because the fiber itself is not enough to feed the boiler. This kind of thing is very interesting. This is why that I saw in one slide that one of the company tried to put the biogas into the boiler. I think this is kind of the thing, Prof. Hadianto. There's still there are some things that we have to do.
Thank you very much. Dear all participants, we still have plenty of time, so we invite you to ask something to Dr. Harsha or Dr. Po. Pak Indro? Yeah, Dr. Indro. Dr. Indro is also working with biogas, so maybe he
that is very interesting. Very interesting. I think also this is opportunity for the Undip, the University of Diponegoro, to do some research on biogas, because what I have said already that there are some still room for improvement. It is really why the people also maybe ask why still the company will the biogas plant, although the performance is not good enough. But because of this is mandatory that people have to capture the methane. This is one thing that we cannot avoid it, even though the cost of investment and the price of the equipment is very expensive. And also sometimes the performance of the gas engine is not as good as we expected. This is one thing that may be very interesting if we do research on the practical basis, not just in a scientific basis.
I'm sorry, I'm so late to follow your discussion.
I invite Pak Indro.
No, I'm sorry, sir. It's so late for me to join with the material. Thank you.
Okay, thank you. Other participants?
In the chat.
Yes, me, Mr. Prof. Hardi. Yanti.
Yes, please, Yanti.
Yes, thank you for the time. I want to ask to Mr. Harsha. Dr. Harsha, what do you think about the opportunities for development of biofuel from lignocellulosic biomass at this time? It's the first question. And the second question, is it possible to develop biogas from domestic waste, like from the vegetables waste, at the smallest scale of the community environment, like one village or two villages? It's possible to develop the biogas from the vegetable. Thank you.
Okay, thank you, Bu Yanti. I think I will answer the second question, that how about the building of the biogas or biogas-based, vegetable-based biogas. the problem of feeding, I think in every electricity generating plant, the problem of feeding biomass is continuity. This is the problem. Yeah? And also the heterogeneous of the material is not homogeneous. Even that I already said maybe minutes ago that for the palm oil, the quality of the biogas itself is sometimes goes down, sometimes mostly goes down. So if you want to build a biogas plant based on the vegetable, then the first thing that must be considered is the feeding, the continuity and the homogeneous of the material. Yeah, this is one of the thing. And then the first question about the lignocellulosic based on lignin, lignocellulosic material, I think it is still far away, although that the possibility are quite promising, because you know that the frond and leaf is still not used as energy, but only used for the organics. So it depends on the government, also in the university, although whether they want to do research. It is a long run of research. I think it's not a short time, but I think it will take more time than just solid or with and solid and liquid waste. I think the pipe is longer. Yeah, I think this is my my answer, Bu Yanti. Maybe you have another opinion about that.
Thank you, sir. Thank you.
Okay. Thank you, Bu Yanti and Dr. Harsa. Any other questions from the participants? Prof. Didi? Maybe Prof. Tutu? And back to Dr. Ho, if he's already available in this Zoom. No, I think he already. Okay, actually our time until 14:30, and we still have 5 minutes left. But if no further question, then we have to end this sessions now. And thank you very much for the presentation, Dr. Harsa.
Yeah, you're welcome.
As I thank you for your participation to all the participants in this second plenary session. On behalf of the committee, I would like to thank and give appreciation to our 4 speakers for their excellent talk. Even though ones are not available, and those presentations give us valuable insight and recent issues in particular research area. I hope all of you enjoyed the presentation, and I also would like to thank you all the participants for your kindly, fruitful, and actively involved in this session. We do look forward to your participation in the future conference in our university. Thank you. Now I hand over to the committee.
Thank you very much for the excellent lectures. Ladies and gentlemen, this is the end of the plenary session. After a short break, we invite you to continue with the parallel session which held on the parallel room from 1 until 6 with the link that has been informed previously.
We also would like to kindly ask you to be in your presentation room at 3 p.m. Jakarta time. As the session master of ceremony, we, on behalf of the committee, we do hope that you enjoy the program and we apologize for any inconveniences during the plenary session. Thank you and good afternoon.
Good afternoon, everybody.
Good afternoon.
Thank you, sir.
Thank you, Dr. Harsa.
Thank you.
Thank you,
Thank
Prof.
you.
Hardi.
Thank you.
Thank you.
Pak Indro, maybe you still remember me. I'm your
Prof.
student. Thank you.
Okay, we'll start at 3 p.m.